Hello, everyone. It's great to be here. Thank you so much for joining us today. So, we are going to start the session today. So, the first of all, good morning, good evening, good afternoon, everyone. I know that people from a different time zone have been joining us. So, I would like to thank everyone who has joined us today for the meetup. I'm quite excited today because of the three primary reasons. The first one is we have three communities coming together for the first time. Yes, you heard it right. We have Docker Bangalore, Collabnix, and JFrog. So greetings to all. This time we received around more than 20 submissions for the CFP. So it was a tough decision to go ahead and select the best 8 out of them. And I'm quite happy that we have a very diverse topic that we selected. So we have eight amazing speakers this time, out of which we have three Docker captains for the first time, and they are going to talk about everything about Docker, Kubernetes, DevOps. So, and interestingly, these speakers come from 5 different time zones. So you can imagine that there has been a lot of effort which has been put for this event to happen. So for few of you who know very less about Docker Bangalore, so Docker Bangalore has grown to be the largest meetup group in India, thanks to all those 10,400 members who are part of this meetup group. Since last 2 years, we conducted around 40 events, which is really a great number. In other hand, we have a Collabnix community, which was basically born out of Docker Bangalore, and today has around 5,500 Slack members. So I would like to thank each one of you for your great support. And then talking about the third community, which is the JFrog community. So I have Ari Waller, a developer relation manager, as my co-host for this event. So hello, Ari, can you hear us?
I can. Thank you so much, Ajit. I really appreciate it.
Yeah, thank you so much for your time for joining us. I know it's quite late for you, but we are really grateful that you joined us. So, Ari, why don't you go ahead and introduce yourself to the audience?
Sure. Hi, everybody. My name is Ari Waller, and like Ajit said, I am the Meetup event manager for JFrog. I have the pleasure of working on the developer relations team, and we are really excited about this meetup today. I have been with I've been with JFrog for a little while now, and it's such an exciting organization to be with. But before I got into JFrog, I actually was in the technical staffing industry for a very long time. So it was just so awesome to be able to take that background and then really be part of the community efforts on a global level, and meeting people like Ajit, frankly, who really have a heart for the community. Just really exciting. But I live in Atlanta, Georgia, and I'm known for a few things. One is my many children. I have 7 children, and we also love to build Star Wars Lego sets together.
Okay.
And very excited to be here.
Yeah, thank you, Ari, for introducing yourself. So before we start with the sessions, so there are a couple of questions which I want to ask you. The first one is,
Sure.
So JFrog today has become a database of DevOps, right? And de facto standard in the release and update management. So can you tell us something about the company and what is your role?
Sure, absolutely. I'll share just a little bit about who we are. JFrog is the DevOps software company. We were founded in 2008, and we're actually known by many for our flagship product, Artifactory, which is the world's leading universal binary repository. In fact, the open source version is easier. Today, we have nearly 800 employees, 8 offices globally, and more than 3 million developers and engineers use our software tools daily.
Okay, that's great to hear. And the second question is, I have been hearing a lot about the JFrog and the Docker partnership.
Sure.
And I know that the JFrog has been providing a kind of an artifactory for all the Docker Hub images to be stored. So can you tell us more about the partnership with Docker?
Absolutely. Yeah, this is one of the most exciting announcements to start off 2021 for JFrog. Through our partnership, Docker and JFrog are providing developers unlimited high-performance premium access to quality and trusted application components on Docker Hub in our cloud version. This streamlines developers' experience while allowing to scale the use of containers in the enterprise. This not only works with our commercial version, but since we're at a community event, we have a free cloud version for people as well, and it actually works there also based on this partnership to utilize the features with Docker. So we're really excited about having that offering also.
Yeah, really excited about the partnership and all these things happening around.
Absolutely. You know, Ajit, I know there's some people here in the JFrog community that may not know you as well. So if you don't mind, I'd like to ask you just maybe introduce yourself a little bit to the audience that may not be as familiar with Docker Bangalore and Collabnix.
Yeah, sure. So I have been using Docker from past, like I would say close to 7 years, highly inspired by the way how Docker works today. I have been a kind of frequent blogger at Collabnix, and that is where my personal journey with the Collabnix all started with. Then during the course of time, I have been getting a lot of queries in LinkedIn and Twitter about how to start with Docker. And that's where I thought that why don't we go ahead and try to bring all those community members under the single umbrella, right? And that is where the Collabnix community was born. So we have around 5,500 plus Slack members today. And
Wow.
it's really inspiring that every day you learn new things from these communities. So that's where how it all started. And today, and I don't want to miss out that we have built a great GitHub repository, so just like Docker Labs, Cube Labs. Docker Labs itself, like it has more than 1 million visits, right? People have been using that for running the Docker workshops. And the second thing is we have a Cube Tools. So cubetools.collabnix.com is a site where you get all those Kubernetes tools. So I would like to thank all those active members who have participated for this GitHub repository. They are highly popular today. And recently we started with contribute.docker.com, where the Collabnix community went ahead. They contributed, especially the site for Docker community, so that we can go ahead and grow it. So it has been around more than 3 years. We have been together in the Slack community, chatting almost every day. And the best part is today, whatever we are conducting meetups are because of the Slack communities as well as the meetup events which we do. Yep.
That's excellent. Well, you know, it's just really exciting. You know, one of the things I've really enjoyed about planning this event with you is just the synergy in terms of really having a vision to see the community prosper in from a technical knowledge standpoint, and that's really at the grassroots of what started with JFrog and still exists today, and it also is the same thing that I see that you practice for the Docker community in Bangalore as well as Collabnix. So really exciting to get things started. Is it okay to share about our little contest?
Yeah. So definitely it is like Collabnix has one of the thing which I really want to share about is the active community members. They have been like, think of it as like almost all the speakers which we get for this community we have been getting it right away. So for conducting any kind of an event, there has been a great support. And in the recent past, we had also been collaborating with few of the universities. So it's always great to collaborate with the community members and come up with building such kind of the tools and technologies, and then day-to-day interaction with them and try to motivate them to because if you look at the way how it has been, it all started with the DevOps. Now it is a DevSecOps. So we had a DevSecOps event which was conducted by one of the community members here, right? So all of these events keeps you highly excited, and I'm really excited to see like how we are progressing as a team or as a community.
That's excellent. That's great.
Yep.
I was going to share one slide before we got started. I know everyone's anxious to get the talks, the talks in play. Hopefully it'll share here in just a moment.
Okay.
Let's see here. It's amazing the challenge of sharing a screen even after the length of the pandemic, but still one of the most important parts of an event. Well, one of the things that we're really excited about at JFrog is we love to share with the community some of our swag, and today we have an opportunity for about 50 people throughout the event today who enter to win a JFrog t-shirt. And it's actually, if you look at the t-shirts that you're wearing and most of the speakers are wearing, that's the t-shirt that you'll have an opportunity to win, as well as a Liquid software book that'll go along with that. And we'll mail that to you. So feel free to enter that raffle anytime today. The winners will be picked and contacted by email within 2 business days. But at the same time, we're going to be giving away 50 to the community. So it's going to be very, very exciting. I love that part of my job, being able to share some of the really cool items that we have with everybody. So there we go.
Okay, that looks great. So, sorry, do you want to take up the stage now?
Sure, absolutely. I want to take this opportunity to, as Ajit brings up, our first speaker. And our first speaker is going to be Melissa McKay, who is a developer advocate at JFrog. She's a mom. She's a Docker captain, a Java champion, and co-author of an upcoming book, DevOps Tools for Java Developers. Melissa's a longtime developer turned international speaker who will be sharing today on the Docker and Container Ecosystem 101, a presentation that she actually shared at DockerCon this year. So without any further ado, we want to welcome Melissa.
Hey, everyone. Hey, I'm super excited to be here. Really happy to be, it is, I think it's 12.5-hour difference or something like that. It's actually 9:45 here right now. I'm located in Denver, Colorado. It's been really hot here the last few days. But other than that, nothing to complain about. I am excited to talk to you about containers today, the Docker and container ecosystem to be specific. We're going to have a new batch of developers new to containers and to Docker every year. And my personal introduction was sink or swim. I found myself wading through a bunch of new terminology I didn't understand, and I discovered quite a few stumbling blocks that slowed me down, not to mention suffering some of the consequences of trial and error. So my goal for you for this talk, the first one of today, is to have a good foundation before you jump into the deep end of containers. We've got a lot of container talks tonight, and sometimes we forget that there may be some folks in our audience that are brand new to this and need a little background. I could have really used a session like this to quickly get me up to speed on understanding the terminology, the different components, and the big picture, and clear up any silly misunderstandings of overloaded terms like container, or do we actually store containers in container registries, that kind of thing. This is our agenda today. As Ari said, I did present this talk at DockerCon, and it was one of the introductory talks, so I hope that you can get a lot out of this today. Right now, I'll just, Ari introduced me already, so I'm going to briefly go through a slide there so you have my Twitter handle and all of that business. And then we'll move on to a discussion of why one might want to get comfortable with containers right now. The history lesson is the heaviest portion of this talk, so make sure you're in a comfortable spot. Get comfortable in your chair where you can absorb this info because it's going to come at you pretty fast. I'll give a brief explanation of the Docker ecosystem, some of this 101 terminology around containers, and then I'll finish off with a few resources for you to go and learn more. Ari already introduced me. Thank you very much for that beautiful background. I have been in the industry for over 20 years, have been a developer at various levels, and a year and a half ago joined JFrog as a developer advocate. I am a Java champion and a Docker captain, and you can find me at on Twitter at Melissa J. McKay. All right, so let's get started. My introduction to Docker was by way of a project that was developed by a third-party contractor. So in my case, this wasn't a decision made by our team at the time. The first thing that I saw when I was ramping myself up on the code base were those Docker commands in the README file and a file named Dockerfile in the root of the project. I'm always up for learning something new, so I was intrigued. What is this Docker thing? This particular project that introduced me to Docker was already designed, code was already written and functional. So in this case, the best thing for me to do was just to dive in and figure out how to set it up, how to build it, and deploy it as it was. This strategy has always worked pretty well for me when ramping up on any project, especially when it involves a new tech stack or framework. Follow those instructions the best you can if you have them. We were lucky in this case to get it up and running. Make note of any difficulties or questions that come up. Adjust the instructions if necessary, and then go back through again to understand how all of those pieces fit together. This is something that you would do repeatedly at the beginning of a project. Right away, I had so many questions, like these questions here, but there was nothing initially stopping me from moving forward. I learned best by doing, so my first step was to download Docker Desktop to try this thing out. Before we get into those Docker details specifically, let's ask the most important question: why would we or should we use containers? I don't know why Docker was chosen for the project that I was tackling at the time. I was not involved in those initial discussions, but as I worked with it and setting up our development environments and our CI/CD pipelines, I saw several advantages. If you're doing the same, and you're thinking of wrapping your applications in containers and going cloud native, just take a moment to consider the problem specific to your project that you'd like to solve. Put these down in writing somewhere. I see so much documentation out there that goes into depth on how to do something without explaining anywhere why. So let's go through this list. The first one here is kind of a joke. Really? You're using Java 11. Well, Java 11 was released in September of 2019. Java 16 just came out recently, but I know so many projects that are still back on Java 8 for various reasons. I know it's frustrating to deploy a nice new Java 11 application to a prod machine that only has Java 8 installed. That's just one example of, a language-specific problem. Obviously, applications that are containerized are not all going to be in Java. I'm just pulling from my experience and my background here. The second item here, I love my MacBook. My workstation is my MacBook. I was introduced to Mac, I don't know, maybe the third position I was in or the third team I was on, and I haven't gone back since. I love it. But how many of you have worked in code that has a bunch of if statements in it around what OS you might have? I had coworkers that were running on Windows. I'm sure there are some legitimate reasons for this, but I'm remembering scars from the browser wars, the web browser wars. But I actually had a situation once where unit tests I ran failed because I was on a Mac instead of Windows. There were some other issues there, multiple problems there to address. One was how it was dealing with the file system. But it is nice to be able to have the option to run unit tests in a container without having to worry about every possible OS. The third item here, there's a bug in production. The first thing you do as a developer is to reproduce the problem. But that's difficult when you're already developing the latest and greatest and you've made changes to your environment that are not backward compatible. Consistency and build reproducibility is key when you're chasing those bugs. Number 4, it works on my machine, only on my machine. That's related to number 2. Again, consistency in software versions and libraries will make your life so much less complicated. Number 5, we just hired 3 new developers. This has happened various times in my career where a new team is started up or new members of the team have joined. That consistency that you get from step 4 will make onboarding those team members so much faster. So number 6, my service is super popular. This is a good problem to have. You've put your service out there in the cloud and now it's getting hit with a ton of traffic. One of the biggest reasons for moving to modularity and to containers is utilizing the strategies of cloud native deployments to quickly scale that application as you need, as load increases. Now you might be asking right now, don't virtual machines solve this problem for us? They have isolated environments. It should be, just fine. But the problem with VMs have their advantages, but they are not as lightweight as containers. VMs contain an entire copy of the OS. So it's not as lightweight as a container, which actually shares the OS of its host with other containers. Even if you're not using containers in production today, there are other scenarios worth considering the use of containers in your development pipeline. Those dev environments. Don't suffer from the disappointment of spending that entire day debugging a problem that you find out happens only on your machine. The test environments. Having that ability to easily launch other external services like databases, that type of thing. Being able to improve your test automation, that's an advantage. And then, of course, production. You may have a problem with securing dedicated resources. I know that I was in a situation where getting a new server set up in production involved quite a few IT tickets and a lot of time. You don't have to wait for custom provisioning or worry as much about inconsistency when you're able to deploy with containers. Now I want to get into that history that I referred to earlier. It's really easy to skip this part when you're eager to get started, but I recommend going through this exercise with any new framework or technology that you want to start using. This will be quite a bit of info, but bear with me because it's worth it. Understanding how we got here and where the tool you're about to commit to for your project, where it came from, can help you avoid some nasty pitfalls and help you use that tool in the most effective way. You know that popular cognitive bias? If all you have is a hammer, everything looks like a nail. This is also applicable here. Containers are useful, but aren't intended to solve everything, yet anyway. All right, in the 1960s and 70s, computing resources were a lot more limited than today. Computers were commonly dedicated for long periods of time to a single task for a single user. Of course, these limitations resulted in plenty of bottlenecks and just general inefficiency. Efforts were started to develop a method of sharing resources without getting in each other's way or having one person inadvertently cause the entire system to crash for all of its users. Both hardware and software that advanced virtualization technology started to trickle in. One development in software was Chroot, which is where we'll begin. In 1979, during the development of the 7th edition of Unix, Chroot was developed and then later added to the Berkeley software distribution, BSD, in 1982. This system command allowed for the ability to change the apparent root directory of a process and its children, which results in a limited view of the file system in order to provide an environment for testing a different distribution, for example. Chroot was a move in the direction of providing the isolation required from us today, and several years later, in 2000, FreeBSD expanded that concept and introduced the more sophisticated jail command and utility in FreeBSD 4.0 release. Its features which were later improved in 5.1 and the 7.2 releases, those features helped to further isolate file systems, users, and networks, and also included the ability to assign an IP address to each jail. In 2004, Solaris containers and zones brought us ahead even further by giving an application full user process and file system space and access to system hardware. Google jumped in with their process containers in 2006. Those were later renamed to C groups, which centered around isolating and limiting the resource usage of a process. In 2008, C groups were merged into the Linux kernel, which along with Linux namespaces led to IBM's development of Linux containers, LXC. You may have heard of those. Now things get even more interesting. Docker was open sourced in 2013. And that same year, Google open sourced their Let Me Contain That For You project, which provided applications the ability to create and manage their own subcontainers. And from here, we saw the use of containers explode, Docker containers specifically. Initially, Docker used LXC as its default execution environment, but in 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer, which is a native solution written in Go. That was something new that I learned. I didn't realize that Docker was written in Go. Soon after, the Let Me Contain That For You project ceased active development with the intention of joining forces and migrating the core concepts of that project into Docker's libcontainer. A lot more stuff happened, but before we leave this, I want to point out something specific that concerns Java applications. In July of 2011, Java 7 was released, and Java 8 was released in March of 2014. Given the development going on in containerization at the same time, it shouldn't come as a huge surprise that older versions of Java are not fully container aware, except it is a surprise. If you don't know this, and you wrap your Java 8 application only to suffer from out-of-memory killer activity. The reason for this is that the mechanisms the JVM used in these older versions to retrieve the resources available come from the actual host machine and not the C group limits that you would expect. Although possible with later Java 8 updates, I believe it's 121, is the best you can get for Java 8. It's recommended to get to Java 11 in order to get that version that is fully container aware. All right, there's a lot more that happened during this period of time. I'm intentionally going to skip over some of those details in order to get to a specific event in 2015. This event is really important to know about because it'll give you some insight into some of the activity and motivations behind shifts in the market, especially concerning Docker. On June 22nd, 2015, the establishment of the Open Container Initiative, OCI, was announced. This is an organization under the Linux Foundation with the goal of creating open standards for container runtimes and image specification. Docker is a heavy contributor, but in their announcement of this new organization, it was said that over 20 organizations were involved in this. I would read that list to you just so that you can fully comprehend how big of a deal that was. These are a lot of companies, a lot of organizations involved. Containerization has evolved to such an extent that this number of organizations wanted to work towards some common ground for the benefit of all. The OCI accomplished some big things. They had in June 2015, when they were established, they had the OCI runtime specification, the OCI image specification, the OCI distribution specification. And in July 2017, the runtime and the image specs were released as version 1.0. On May 4th, 2021, the distribution spec was released, again, version 1.0. Docker had a lot to do with these specifications, and I'll talk to you more about what those contributions were in a minute. One month after the OCI was established, the Cloud Native Computing Foundation, or CNCF, was established. The CNCF does a lot. There's a ton of projects there that are either incubating or graduated under its umbrella. There are a few activities there that you need to know about for our purposes. Along with the developments in the container ecosystem, orchestration was also in rapid development. Orchestration frameworks like Kubernetes took on the responsibilities of the coordination, configuration, and management of containers in deployment environments. Kubernetes version 1.0 was released at the same time the CNCF was announced. Kubernetes was contributed by Google and was the first project that was brought into the CNCF. Right on the heels of that first release, version 1.5 came out, which included the Container Runtime Interface, the CRI. And there's that word again, runtime. So what exactly is the Container Runtime Interface? That CRI is a level of abstraction that allowed the Kubernetes kubelets to support alternative low-level container runtimes. The Docker, the company, also a member of the CNCF, and well on their way to breaking up that huge tech stack we know as Docker, contributed their CRA-compatible runtime called Containerd. Containerd was developed in order to integrate runc into Docker version 1.11. All right, congratulations. You made it through that history lesson. I know that was a lot of information, and you might have even more questions now, but you have some description of a lot of those keywords, a lot of the main projects that you hear about in the ecosystem. Hopefully, you won't be so bogged down with all of that new project information when you begin on your Docker journey. So Docker does all of these things in this list, and it does it well enough that its popularity is unmatched here. Note that when you hear of talk of container runtimes or image formats, what's being discussed is a small piece of that whole package, that entire tech stack, which is described here. The ability to define a container, building an image of a container, managing those images, distributing and sharing those images, creating a container environment, and the concern of launching and actually running a container on your machine. And then, of course, managing the lifecycle of those container instances. Let's talk a little bit more about container runtimes. This can be really confusing for someone new to the world of containers. The Docker tech stack obviously contains a lot more than just the runtime. Docker did quite a bit of reorganizing their code base over the last several years, developing abstractions and pulling out discrete functionality. One of the results of this effort was a project called runc, which I mentioned before, which was contributed to the OCI. This was the first and for some time the only implementation of a low-level container runtime that implemented the OCI runtime specification. There are other runtimes out there, and as of this writing, this is a very active space, so be sure to reference the current list that is maintained by the OCI for the most up-to-date information, and I can provide you those links. I actually have some links at the end of this slide deck that will help you get there. Other notable low-level runtime projects include CRUN, an implementation in C that was led by Red Hat, and Railcar, an implementation in Rust, which was led by Oracle. That project is now archived, but it's interesting. Developing a specification is really challenging, and collaboration on the OCI runtime specification wasn't any less challenging. Figuring out where those boundaries are, what should and what should not be included in the spec, took some time before the release of version 1.0. It is very clear, however, just implementing that specification isn't enough to drive adoption of an implementation. Additional features are needed to make a low-level runtime usable for developers, since we're concerned with much more than just the creation and running of a container. This leads us to higher-level runtimes like Containerd and Cryo. These runtimes include solutions for many of the other concerns around container orchestration, including image management and distribution. Both of these runtimes implement the CRI, which eases that path to a Kubernetes deployment. Both of them delegate low-level container activities to the OCI-compliant low-level runtimes like runc. That brings me to a point, a question that I get a lot. This here is a link to a really good blog. In short, Kubernetes is deprecating the Docker runtime. And that caused a lot of panic, really because I think most people don't understand what that actually means. In short, that deprecation of Docker runtime support does not in any way, shape, or form mean that Docker is going anywhere or losing support in other ways. You can still use Docker to develop and produce Docker images and containers as you do now. Basically, what happened is Docker the Docker runtime was originally the original implementation of CRI compliance, but it was through a specific component called the Docker shim. That basically Kubernetes wanted to get rid of that. It was a customization that wasn't necessary for any of the other runtimes. Plus, when Docker hit version 1.11, they started using Containerd, which is CRI compliant. So it really doesn't make any sense for Kubernetes to support the entire Docker tech stack anymore in order to support that Docker runtime. All right, we're getting to the end here. Now we get into just some simple terminology of containers. What is a container exactly? It's a running instance on your machine. What is a container image? That's an immutable executable binary used to create a container. This is usually a made by a Docker file, which is a text file that is a set of instructions that is used to build that image. An image tag indicates the version of the image. Excuse me. A container registry is a library of container repositories and images. And the most popular example is Docker Hub. That is the default central storage for Docker images. And an image repository that stores all of the versions and tags of an image. So generally, that's the image name. All right, what now? You have all of this information. You've got some terminology behind you. Now it's time to just download Docker Desktop. Back when I first downloaded this application, excuse me, I've got a frog in my throat. I work for JFrog, and that's what happens. Anyway, back when I first downloaded Docker Desktop, it was simple. It was easy to work with. But when I look at it today, so many improvements have been made around the UI. You don't even have to use command line commands to look at your images or look at the info behind them, any of that. You can do that all through the UI now. It's pretty cool. The documentation at docker.com it's very, very good. They have a whole getting started section, which is definitely worth working through. The CNCF website is here. You can find a lot of information about how to get involved in those organizations. It's really important that companies and organizations get involved in these so that we move in the right direction for future components, future development around cloud native technologies. And then, of course, opencontainers.org. This is where you can find all of the links to all of the specifications that I talked about earlier. The runtime specification includes a reference to like all of the current implementations that are available right now. And if you go there, you can find not only the current low-level container runtimes, but you can also find work that's being done in VMs as well. All right, I am ready for some questions if you have any. I think we have a couple minutes before we start with our next speaker. So I don't know if anything came up. I'm going to take another drink.
I was just going to say, Melissa.
My throat.
Yeah, there's we have frogs, but I mean, we never have. But this is taking it to the extreme. I love it. Let me ask you, Melissa. Would you prefer to answer some questions, to go onto the YouTube channel and take some questions there in the chat? There you can drink as much water as you want, and
I'm putting in a cough drop right now.
We'll do that.
I would like to answer this question that's up here for sure.
Sure, absolutely, please do.
Okay, what does it mean by being an application being container aware? As is a container is subset OS, which can run application in isolation. Okay, so mainly what I mean is, for Java applications specifically, the way the JVM handled resources. For example, when you launch a container, you can tell that container only use this much of memory on the host, only use this much of processing power on the host. But for a Java application for older versions, it ignored that. It wasn't using, it was getting the wrong number, basically. So you could launch a bunch of containers on an OS, and then they could all stomp on each other because they're all taking resources from each other. So that's what I meant by container aware. There wasn't good enough isolation there.
Thank you. That's awesome. Also, there was a Git repo you were talking about. Somebody actually wanted to know if you could share the Git repo information.
A Git repo.
Yeah, I think it was near the beginning of the talk. Maybe you made reference to one. If
I may have. Let me go find it.
Okay.
It might be the Open Containers repo.
Okay.
I can go. I'll find that question and I'll post that in the YouTube channel.
Awesome. Well, thank you so much for the awesome talk. I know that it's always great to get back to the roots of what you're doing, and I know that was really, really appreciated by many here, and I always enjoy that talk. And thanks again, Melissa.
Sure.
I think Ajit's going to come on, and he's going to introduce our next speaker.
Okay, can you hear me? Okay.
Yeah, I can hear you now.
That's great. So personally, I really like the first session because it is more about Docker, how to get started with Docker, CNCF, all those exciting stuff, right? So we have our next speaker, who is an associate director as Cognizant Business Consulting and Founding, board manager of TMI Foundation in North America. With over 20 years of industry and 21 years of certification, we are privileged to hear him spare his expertise on improving AppSec while building DevSecOps pipeline. So let me go ahead and add Suresh. Suresh, can you hear us?
Hey, sorry, I was on mute. Can you hear me now?
Yeah.
Hey, Ajit.
Okay, Suresh, over to you.
Can you see? Let me see.
Yeah, I can see your screen. Yep.
Can you see my video?
Yep. I can't see you. Maybe you have to turn off your camera.
Oh, yeah.
Yes.
Yeah. Okay.
Now it works. Yeah.
All right. Great.
Okay, over to you.
All right. 1 second. Okay. All right. So good morning, good evening, wherever you are, and greetings to you all. This is Suresh Chandra Bose. I'm really very excited to speak about how we can improve the AppSec while we build any DevSecOps pipeline.
So Suresh, can you go full screen? You can just play the slideshow.
Okay. Able to see.
You can click on the slideshow on the top.
Yeah, I did that. Are you able to see the full screen now?
No, we do see all your slides here. Maybe you have to click on the slideshow on the top.
I did that.
Okay, let me remove and add it to the stream again. So can you try now? Okay, go ahead. No problem.
Yeah. Oh, is not able to see the full screen?
No, we do see. So on the top, you see here, right? There is a slideshow. So is it not working?
It works on my monitor. So I don't know. All right. So I think.
Okay. Go ahead. No problem.
1 second.
Okay. Go ahead.
Try something. Is it okay now or still?
Yeah. It's okay. Go ahead.
Okay. All right. A little brief intro about me. I am based out of Austin, Texas, and I work for Cognizant Digital Business Consulting. I started my career in development, and then I moved to consulting with overall 23 years of industry experience, and I've been part of multiple continuous delivery transformations. I performed 100 plus assessments for various clients across the globe, and I have enabled them to succeed through the different transformation journeys. Right? I'm also privileged to be the first TMI lead assessor in entire North and South America. I'm not sure how many of you are familiar with TMI test maturity. It's something similar to CMMI focus on testing. Right? And I've completed 21 certifications so far, and I've been a speaker in many leading conferences like DevOps Days, ASTQB, PNSQC, ASQ, and I'm really, really excited to be speaking in this JFrog Docker's meetup. Right? Special thanks to the organizers for being so flexible. I was initially supposed to be the last speaker of this event, speaking at 2 a.m. my time, but I think you were very flexible enough to change it a little earlier. And thank you, Ajit and Ari, for it. All right. Can you see the next slide? Ajit, can you confirm?
No, we don't see the next slide. I still see the same
Something
slide.
wrong. 1 second.
Yeah. Now we can see. Yeah.
Okay.
Yeah.
All right. Okay. Well, I think this would be one of the questions which runs through many of your head, right? What is DevSecOps? And I know there's a lot of buzz around DevSecOps of late, right? But again, it's nothing but it's a way of approaching your IT security with, and everyone is responsible for security, that kind of a mindset. Basically, you try to inject your security practices into the organization's already existing DevOps pipeline. Right? So the goal is to incorporate security into all stages of your software development lifecycle without adding any kind of a gatekeeping or bureaucracy. If your client is already doing DevOps, then I think it's a very good idea to consider shifting towards DevSecOps. All right. Why DevSecOps? So what you see here, right? This is a result of the recent survey which was conducted by Synopsys. I'm sure most of you might be aware. Synopsys is one of the leader in the Magic Quadrant of Gartner in terms of the application security testing. Right? If you see the results here, you can see there is very limited focus is given to the DevSecOps tool adoption, right? And hence the need is huge to increase investments in various tools to have a very secure product. You invest a lot into your applications, but you want to ensure that it is safe, right? I'm sure most of you use either Apple or Android phones. And the statistics say that 85% of the applications from the public app stores like Apple Store or the Google Play, they violate at least one or more of the top 10 vulnerabilities that have been identified by OWASP. So that shows even our mobile phones are prone to attacks, and hence the importance of DevSecOps is even more prominent today. Okay. So let's get into the different aspects. In fact, there are 4 aspects, or I would say 4 pillars of your delivery, of your continuous delivery pipeline. And again, this is from SAFe, right? So if you see the SAFe continuous delivery pipeline, so there are 4 pillars, right? Continuous exploration. It starts from continuous exploration, then it goes to your continuous integration and continuous deployment and release on demand. I'm sure every one of you here should be familiar about what I'm talking about, right? If not, I'll just give you a gist of it. Continuous exploration, they focus on creating alignment on what needs to be built. Right? That's going to be your first pillar in your DevOps pipeline. And then you have your continuous integration, CI. Right? So that takes, you take your features from your program backlog and you start implementing them as part of your CI. Right? Once you implement it, you have your continuous deployment. So basically what you do is you take the changes from your staging environment and then you deploy them to the production environment where it is ready for release. Right? The last pillar is the release on demand. So basically you have, you can make your releases available to the customer at any point. I mean, it can be all at once, or you can even do it at a staggered fashion. So it could depend on multiple situations or conditions. It could be based on the market conditions or based on the business needs. You might release it immediately or you do it in a staggered fashion. Right? So that is basically what is all about on the release on demand. Right? And now what we are going to see is how security is getting embedded into all these 4 pillars. Right? So that's our key messaging today. Right. All right, let's start with security and continuous exploration, which is the first pillar. Right? Okay, so as organizations become more digital and cloud-based, right? So the IT systems, they face a lot of risk. There's more vulnerability. Right? With more technology, what happens is you're prone to more security issues, more vulnerabilities. Right? So that's one of the reasons we recommend threat modeling. So basically, it is a process which happens much early in the phase. You'll be able to identify your threats. It's not just identifying your threats. You'll be able to mitigate them with a structured model. So that's what is all about threat modeling. It will basically help you to identify your security requirements. You'll be able to pinpoint security threats and any potential vulnerabilities. You'll be able to quantify your threats, not just identifying or pinpointing your threats, right? You can quantify your threats, and there's something called vulnerability criticality, right? So you'll be able to quantify them as well, and you prioritize the remediation methods on how to mitigate them. So these are basically the key events that happens within the threat modeling. Right? I'll get a little bit deeper into this threat modeling. If you see what happens off late is a lot of consulting companies, they have started using threat modeling as a service, TMAS. And basically there are 4 important steps here which are critical in threat modeling. Right? What are we building? That's the first step. So typically, you study your data flow transitions, architecture diagrams, data classifications. So you kind of get a virtual model of the network that you're trying to protect. Okay. Second is identify threats. What could go wrong? Basically, you're using this threat modeling method to further analyze the specific threat types, identifies potential threats, map all the data flows, and you'll be able to quantify your risk here. Okay? The third step is going to be mitigate. What are we doing to defend against these threats? Okay? So in this step, you will review the layers of your application, which will basically, you will identify the threat, the security controls, which is related to your threats. Vulnerability categories are identified. I mean, they'll help you to focus on the areas where mistakes are more often made. Okay? The last step is validate. Have you acted on each of the previous steps that we saw earlier? So this is a very critical element, validate. Right? Let's get into the continuous integration. So how security is heavily built into these pillars. In fact, this is a very critical element of all the 4 pillars. Right? We just discussed continuous exploration, where the focus is on the threat modeling. But whereas in continuous integration, you see, I mean, there's a lot of different elements of security which has been built into this pillar, right? CI pillar. I think let's go through one by one. I think most of you would be familiar about these things, but I'll just give a gist of these different elements. We'll start with the security ID plugins. So basically what they do is they give the developers direct feedback with analysis when you start writing your code. Right? This happens even before your code is checked in. Okay? And there are some very good plugins available in the market. IntelliJ and Eclipse are very prominent ones. Okay? The next is code reviews, pair work. Code reviews, you're able to assure certain code qualities with your code reviews, right? And based on the pattern that comes from multiple code reviews, you can automate the rules inside your code analyzer. And pair work is based on the extreme programming. It provides real-time feedback directly during your design, or it could be your coding, right? Wherein what you typically do is you temporarily pair the team, your developers or your agile team, right, with a security expert. So that's basically, you call it pair work. Okay? And the third is going to be a very critical element, SAST, static application security testing. Some call it a white box testing, where you use the SAST tools that will basically scan your source code of your application. So by scanning, you'll be able to identify potential security vulnerabilities in your architecture, in your software. So SAST is a very critical element of your DevSecOps pipeline, as these SAST, these static analysis tools, they can detect almost like 50% of your existing security vulnerabilities. Very prominent tools out in the market. SonarQube is one of the leaders here. You also have other tools like CAST and other prominent tools. Third-party scans, right? So any third-party library or component should be scanned by your static code analysis. Okay? So in fuzz testing, what you do is you randomly feed some invalid inputs or some unexpected inputs. So you feed those inputs and data, and then you try to find any kind of a coding errors or some kind of a security loopholes. So that's what basically happens in fuzz testing. Now, once your code is ready to be shipped, it can be code signed, where you put a digital signature on a program or a file. Right? So its authenticity and the integrity can be verified upon the installation and execution. Next is your security, the infrastructure scans, right? So you basically assess the security levels of your infrastructure, including your malware, right? In your application servers, in your databases, in the open ports, and as well as components such as old SSL or your DNS versions. The infrastructure as code practices, they are adopted here, and IAC scans are done to secure your IT infrastructure. And you do your malware scans for your SaaS infrastructure before packaging any of your components. Right. Coming to the other element of continuous deployment. Okay. Oh, sorry, I missed the one second. I missed the DAS part, sorry. So finally, if you see here the last element, the continuous in your continuous integration, we do dynamic scans, or DAS, you call it DAS, right? Dynamic application security testing, which is also called white box, not the white box, the black box testing. Right? Why we call it black box is because you do not have any access to the code component, unlike SAST, where it is called white box testing and you have access to the code. Right? So the goal here is to identify your potential vulnerabilities that may have been missed by SAST. Right? So SAST, if anything has been, if you miss anything, again, 50% of your vulnerability gets detected in your SAST. And if anything is missed out, probably DAS is one area where you will be able to find them. All right, continuous deployment practices related to testing. In the previous pillar, we saw multiple different elements, right? But here, pen testing is a very critical component of your continuous deployment practices. It is also called ethical hacking. Unlike your SAST and DAST, pen testing, they call it pen testing or penetration testing. Right? Pen testing does not necessarily focus on your code or your software. It also focuses on your overall component, your overall system. It includes your hardware, it includes your operating systems, not just the software alone. It could also include any kind of a human component as well, right? Because there could be vulnerabilities from any human component to your social engineering attempts as well. Right? What we saw earlier, I mean, everything was automated. SAST, DAST, they were all automated. But in pen testing, it's a manual test, which is typically performed by some kind of a security professional. Coming to the last element of your, I hope you can see my screen. Okay. Release on demand. So how security practices are embedded in release on demand. Right? So if you see here, continuous security monitoring. So basically they monitor your system using automation to find any potential security breaches. So this is usually done by a security information and event management system, SIEM. Right? The security incidents, if any, they are logged, and the security response team, they gather information about newly discovered vulnerabilities, and they feed this information back to the development and the operations team. The application providers, so what they basically do is they issue these security bulletins wherein they inform your customers about the newly found vulnerabilities and if there are any measures that they're taking to mitigate or fix them. Right? So that's what you see here, security bulletins, security mailboxes. Right? Well, we saw a lot of different security security components within your CI/CD, your entire 4 pillars of your DevOps pipeline. Right? I would also like to talk to you about few best practices that will make your DevSecOps process run smoothly. Right? If you see here, I mean, there are like seven different best practices that you see here. Right? Everything has to be automated. Again, DevOps itself is automation, and DevSecOps, obviously, it has to be automation. Right? So everything automation is definitely good here. And we want every element, every component, every area, every pillar to be automated here with shift left practices for better effectiveness, for better efficiencies. Right? And you create security champions who are part of your existing team or your release trains. Right? Training is an important component. You train your developers on security, and you're not going to burden them to become a security expert. Right? But we want the team to be trained on different security practices, different security tools. Right? So training is a key element here, like automation, shift left, security champion training, threat modeling, which we saw earlier, right? We do threat modeling and continuous exploration much early before even you start your build. The other important practice is implement strong version control on all code and code components. Right? And again, our focus is going to be first on identifying and removing known open source vulnerabilities. Okay? So that's a key, very key element here. And I'm not sure how many of you are familiar. White Source, they are the #1 leader in this particular space. Right? They're known for handling all open source vulnerabilities. Well, we saw a lot about DevSecOps, different practices, right? Well, how do you ensure that DevSecOps is successfully working in your organization? Okay. There has to be some means of or measure, right, to see that the DevSecOps practices are really working well or not. So here's some of the metrics that we see here, right? So 6 metrics. There could be more, but I think these are the top 6 metrics that have been used in various organizations to evaluate the effectiveness of your DevSecOps implementation. Reduce total security tickets open. So if the count of your security related tickets that are open are coming down, then your DevSecOps practices, your DevSecOps tools are effectively working. Okay? So that's why this is a very important metrics. Reduce total security tickets open. The next is reduce time to deploy. Okay? We saw threat modeling, which we do much early in the phase of the project, right, of your DevSecOps pipeline. Threat modeling, and there are other security practices, shift left practices. Okay? With these combined elements, you're able to identify and fix your security related defects much early. Okay? And thereby you're able to reduce your time to deploy. Okay? So everything is faster now. So you're able to measure how much time you're taking to deploy your application. And obviously, I mean, this metrics has to significantly come down drastically, right? It has to reduce over a period of time, having all your security practices embedded into your DevOps pipeline. Third is discovery of your pre-prod vulnerabilities. So this is something similar to your DRE. I'm sure most of you are familiar with DRE, defect removal efficiency, or some companies, they call it defect containment, right? Where you're trying to contain maximum defects or your vulnerabilities in the pre-prod and not getting leaked onto the production. Okay? So that is, it's a very key measure. Ideally, you want to contain every security vulnerability or threat in your pre-prod itself, rather than seeing that in the prod. Otherwise, it's going to be a very costly rework if there is a leakage into the production. So that's why you have to make sure, take every measure to discover all the vulnerabilities in the pre-prod itself. Right? The next is reduce time to remediate. Okay? And there's strong collaboration here, right, among the DevSecOps team. Strong collaboration. You also have shared responsibilities that we saw on the earlier. Right? That's going to be the key here. Okay? And because of all this strong collaboration, so you should be in a position to remediate defects, security-related defects, much faster. So the time taken to remediate your defects, your security-related issues, has to significantly come down. Percentage of security audits passed. If your security audit is not passed, then it reflects very badly on the entire team. Right? So you may say, okay, well, the chief information security officer, he is accountable at the org level. Yes, he is accountable, yes, but the entire team is responsible for security. Right? That's why in the beginning I told you DevSecOps is everyone's responsibility, and that is the mindset we need to have. Everyone's mindset. Security has to be ingrained. I'm responsible for security. It's not just one particular group or team is responsible. Everyone is responsible. This metrics should continuously improve. Ideally, it has to be 100%. 100% security audits pass. The final metrics is reducing failed security test. So when a release gets rejected, assume there is a security failure, right? What you do is you just reject that release. It impacts every other metrics that we saw earlier, and it has serious consequences. You miss the time to deliver, right? And the dev will have to rewrite the code, and the team has to identify and fix all the vulnerabilities that has been identified. Okay? So hence reduction in the security failed builds. It's an important metrics to deliver better and safe product. So those are some of the metrics, important DevSecOps metrics to see that your implementation is working well or not. Right? Well, you may be wondering, okay, well, with all these DevSecOps practices, what are the benefits that I'm deriving? Let me quickly get into those benefits, right? So if you see, the speed of your software delivery obviously will improve when you have security integrated into the pipeline. So faster delivery. And security is a feature from the design phase onwards. And as I told you earlier, it's a shared responsibility. And hence you see this security posture getting improved, right? As I told you earlier, shared responsibility mindset. Security is everyone's responsibility. So when this gets ingrained, you can see the security posture getting improved across the teams. Okay? And now we're able to identify your vulnerabilities and bugs before deployment. So you'll be able to see your costs getting down, the risks are lower now. Right? So the operational costs will drastically come down. So reduce cost. So with this shared responsibility and your improved security posture, you'll be able to see the integration of your security practices that will enhance the value of your DevOps chain. As security is tightly integrated, there is more agility here. Right? You can see the improvement in the pace at which the applications are getting delivered. Right? Back in those days, I mean, the delivery happens very rarely. I mean, maybe once a month or so, right? But now I think there are organizations where you can see, I think 10,000 applications getting delivered in a single day. So everything is all about agility. Right? Pace. We want things to be done faster, quickly. Okay? More releases happen in a single day. And especially if you take the example of Amazon, they are very, very aggressive in this particular element in terms of speed, having multiple releases in a single day. Finally, with greater trust in the security of your software, of your developed software or the product, right? You will be able to succeed in meeting your business objectives. So we start embracing a lot of new technologies, right? But eventually we will be able to meet your business goals, your business objectives. Okay? So that's a very critical component, right? Business success is everyone's success. That's how you measure the success of your product. So these are some of the benefits that you typically see by having your DevSecOps pipeline, right? You can feel free to contact me either to my email or to my LinkedIn in case if you have more questions that I'm not able to answer as part of this discussion. I'll try to answer it in case if you have more questions or if you would like to contact me, I think feel free. I mean, you have my details here. And finally, a big thank you to the organizers and thank you all. If there are any questions, I think I should be able to take it up now.
Thank you, Suresh, for such a wonderful presentation. I was just going through it, and through the comments. So Suresh, there are a few of the questions, one from my side too. So the question is like, don't you think that the DevSecOps should be part of DevOps? Because with that, we are introducing new terminology itself. So what are your thoughts on that?
I think down the line, I mean, see, this is a very new practice that got built into it. So we started with DevOps, right? So that's why we are all familiar. I think most of the organizations, they've started implementing DevOps. And when we started implementing DevOps, I think that's when we were able to identify a lot of vulnerabilities. And I think this whole concept of DevSecOps came into the picture. We need to have this security mindset into DevOps pipeline. I'm sure down the line, maybe after 5 years or 10 years, there will be a unified, there won't be any separate DevOps or DevSecOps. I'm sure it's going to be only DevSecOps. Wherein you will have both security elements as well as DevOps elements.
Yeah, and that's true in a way, like, even I have been attending a lot of sessions where people are, especially the industry expert, do believe that, security has to come inbuilt, right? For each and every product, what my experience is security should be the mandatory factor for any application. And that has to be built, because whenever you go ahead and build such kind of an application, so the thing is, it has to be secure. Otherwise, anyone can go ahead, break the system, right? So we
Still,
have,
it's still a
yeah,
long way to go, but that's definitely going to happen.
okay, okay. So Suresh, there is one more question here. How do these security plugins that integrate with your IDE differ from the SaaS tools?
Okay, so how is the security plugins different from your SaaS tools, right?
Yep.
Okay, so basically SaaS and the security ID plugins are a little different. So security plugins, as I told you earlier, you have that's a very important tool in the market. So once you start writing, this is mainly for the developers, security ID plugins. Right? When they start writing the code itself, that will give the developers. Um, um, I mean, even before you check in, right? When once you start writing itself, it will give you the analysis. It will help you to identify some the potential vulnerabilities once you start writing your code itself. Whereas task is like it mostly done may not be done by the developers in most of the cases. It could be a separate team from the testing also, testing team. Or there are a lot of tools available in the market. SonarCube is my favorite tool. So they what they do is they just go into your architecture. They study your architecture, not only your code. They also study your architecture and see what are the different vulnerabilities that could happen. So security ID plugins, it's open to your eye. I mean, once you start writing your code itself, you'll be able to identify with those plugins. But whereas SaaS, the moment the code is run into this particular tool, you have to input that the code into this particular tool. It doesn't happen in front of your eyes. You have to feed this information to the code, or basically your code into this tool, and the output it will tell you different set of metrics. It'll throw you. I mean, okay, your code. In fact, there are some metrics out by these SaaS tools. It will tell you that your code is really bad in terms of these are the areas where it's bad. It doesn't give you a very immediate feedback before you check in, but this is like a little different.
Okay. Okay. Thank you, Suresh. Keeping the timeline in the mind. Thank you so much for your time. And it has been great. It's a late night for you, but thank you so much.
Thank you.
Okay. So wanted to add Ari back. Ari, can you hear us?
I can.
Okay.
That's
Over to
awesome.
you, Ari.
Well, you know what? Now I get to introduce you, Ajit, as our next speaker. I appreciate you taking the time to put something together for us, and a great topic at that. So it's my distinct pleasure to introduce my co-host, Ajit Raina, who is the Developer Relations Manager for Redis Labs. Ajit is also the leader of the world's largest Docker Meetup Community. He has written written over 250 blogs, and he's an award-winning Docker captain, founder of Collabnix. And Ajit's worked as a solution architect, an IT consultant, systems engineer, and product advisor. And he's really used his gifts and talents to benefit his fellow technologists in the Bangalore community and really also globally. So today, he will speak to us on extending Docker and Kubernetes K3s to IoT Edge. And without any further ado, we'll turn it over to you.
Thank you, Ari. So just need one confirmation. Can you see my full screen?
Let's see. Now I can. Yes.
Okay. Thank you, Ari. Okay, fine. So hello, everyone. Thank you so much for being with us till now. I know that there has been a lot of great speaker lineup, who are talking about DevOps, and then Docker, and then Azure, and a lot of other stuffs related to the DevOps and DevSecOps. So today I bring you a very interesting topic on delivering a Docker on K3s to IoT edge device. So this year I have been working very heavily on IoT edge devices. So without any further delay, let me go ahead, share you an experience. And this is going to be very lightweight talk. So hopefully it should be interesting for you guys. So a little about myself. I am a Docker captain as well as an ARM innovator. So there are around 35 to 40 ARM innovators today. ARM innovators are those community members who goes ahead and play around with the ARM devices. So I have been actively working with few of the ARM innovators in building very exciting stuffs around IoT. I am author at Collabnix.com. Collabnix is my personal blogging site, which I started writing in 2013. There are around 250 plus blogs, which I have written on Docker, Kubernetes, cloud, DevOps, and IoT. I'm also a Docker community leader. I have been managing a huge community here in Bangalore, as well as conducting events like OSConf, Open Source Community Conference. My full-time job is at Redis Labs. I'm a developer relations manager at Redis Labs. I have been growing the Redis developer community. So if you go to developer.redislabs.com, I am right now full-time into it, adding more and more content to for the Redis community. In the past, I have worked in Dell, VMware, and CGI. I was with Dell for around 8.5 years. Working in a bunch of very exciting stuffs around Docker and the solutions like system management tools on top of Dell servers. Let's talk about cloud native on IoT. Now, we have been talking about cloud native applications, but how does this cloud native looks like on IoT edge device? Primarily, I am going to choose a Jetson Nano board. This is an IoT edge device. The reason being, Jetson Nano today brings the cloud native to the edge. And now, what does it mean? Now, if you look at the cloud native, it is not just about containers. Okay, it is all about DevOps. It's more about how you how you deploy the application rather than where you deploy the application. And these cloud native application could be a DevOps. It could be in terms of containers. It could be in terms of CI/CD platform. So right now, if you ask me, which is one IoT edge device which brings the cloud native to the edge, and the answer is Jetson Nano. This is like a $59 small IoT, a tiny like credit card size device which can fit into your pocket, and you can run an AI workload on top of it. Isn't it interesting? So now when we talk about Jetson Nano, right, today we have a support of Docker on Jetson Nano device. Now, for many of you, you might be knowing about Raspberry Pi. So think of it as like it's a big brother of Raspberry Pi with GPU inbuilt on top of it. And during this talk, I am going to show you when you get started with the Jetson Nano board, what are the things which are supported today? Because it does matter when you can purchase this $59 device and start running containers on top of it. Now, one of the main thing when you talk about Jetson Nano is the Jetpack. Now, Jetpack is basically it is a software which gets installed on top of it. It is basically shipped with the SD card image of Jetson Nano, and it comes with NVIDIA container runtime with Docker integration, enabling the GPU accelerated containerized application on Jetson platform itself, which means that today developers can package their application on Jetson with all the dependencies. Now, this is how the Jetson Nano looks like. So if you are seeing it for the first time, it's a complete computer system itself. So think of it as like it's a complete laptop which has USB drives, and you have an HDMI port, and even USB 3.0. Like you can expect a high speed out of it. You have a GPU card into it, micro SD card slot. Now, a micro SD card slot is just like a hard disk for your laptop, right? So it's same way you can use like 128, 256 GB of micro SD card, and you can install, run, and complete operating system on top of it. Okay, so Jetson Nano today comes in two variants. One is 2 GB and 4 GB. The 2 GB cost around $59 and 4 GB cost around $99. Now, talking about the Jetson software for AI edge device. Now, when you buy this product and when you use the SD card image, it basically comes with the stack, the software stack. And the overall boxes which you see here, the tensor RT, powering the deep learning, computer vision, accelerated computing, these are basically nothing but containers. So these are in the form of the containers which is shipped by NVIDIA to you, which means that for an AI computer to be AI compliant and to be sufficient enough to run the AI workload, you have all those containers running on top of the Jetson device. And with that, you can do all the deep learning stuff like object detection, pose estimation, path planning. You can see basically the path tracker, right? How the object has been moving. And Deepstream is more like a deep learning platform. It is like a real-time streaming which is provided in terms of the containers. Okay, so this is how the Jetson software on top of AI edge device looks like. Now, to get started, what do you need? You need an SD card, you need a USB keyboard and mouse, computer display, micro USB power supply. So the power supply has to be like 5 volt, 4 ampere to get it up and running. And then you have an SD card image which you can download it from here. Now, now to start looking at the first and foremost thing, there are two components which I'm going to talk about. The first thing is the Docker, and the second thing is the K3s. So let's talk about the Docker. Now, the Docker support for NVIDIA Jetson Nano comes by default. Now, this is really interesting. Today, if you talk about Raspberry Pi, you have to go ahead, install Docker on top of it, even though it is officially supported. But if you have an SD card image, if you flash it on Jetson, the Docker comes by default. And the another interesting fact is you have 20.10.2, which is the very latest version of Docker, which is shipped. So just keep that in mind, because you save a lot of your time in compiling the Docker itself, right, on top of the Jetson Nano. The second thing is, if you want to install the latest version of Docker, the way how you do it, you install the latest version of Docker with this curl command, enable the NVIDIA container toolkit with this sets of command, and then you have to install a very, very important package, which is called as NVIDIA Docker 2. Now, this is the package which basically helps you your containers to use all those NVIDIA drivers, which is in the Jetson Nano, right? All those drivers are compiled so that your containers can talk to your hardware. And simply you can go and say Docker run ARM64 v8. This is an architecture. This is the name of the Docker image repository, and then Ubuntu, and you can just run it as the usual you run it on your laptop. Docker Compose support for NVIDIA. Now, this is one of the feature requests which I raised in 2019 at I think in the month of March or April, and I'm really excited to share that now we have support of Docker Compose for NVIDIA Jetson Nano. All you need to do right now is you have to go ahead, install these softwares, and follow these steps. So it needs libssl dev and libhdf5 dev, so to be installed on top of it. And as you can see here, I have 1.26.2 Docker Compose version, which is installed on top of Jetson Nano. Now, you have a Jetson Nano, and Jetson Nano comes with a GPU device. Now, how your containers are going to talk to the GPU device through Docker Compose, and this is how you have to specify the YAML file. So Compose services can define your GPU device reservation by specifying the services like the test, where I'm specifying, okay, NVIDIA SMI is a command, okay, which works really great with CUDA. And a CUDA is like an API, how the Docker containers, or how you are going to talk to just like a web services. Like when you talk to any hardware, there should be some API, right? Like for the x86 Dell servers, which I can say there is the API called as Redfish API. In the same way, we have a CUDA as an API, which allows you to go ahead and talk to the hardware. So the way how you define is, this is the Compose, how it looks like, and you just have to go and say Docker Compose up, and your services are going to now use the GPU. Now, With the latest release, the CUDA 11, I noticed that NVIDIA SMA is no longer available. So if you are following my blogs, so if you go to the Google and type Docker Jetson Nano, so the second link which you get is points you to my blog, which might not work today. The reason being, with the latest release, NVIDIA SMA is not shipped to the Ubuntu. You can use a tool like JTop, so you can use Ajeet Raina / Jetson Stats Nano as a Docker image and run JTop, and you will get a real-time statistic of your CPU, GPUs, and the disk. Now you can check the Jetson CUDA information. As I said, it's an API to talk to the GPU devices. You can use the Jetson Jetson utilities GitHub repo, where they have a Python script which displays all the CUDA, OpenCV, TensorRT, VisionWorks. So right now, do remember that there is no support of CUDA 11 for Jetson board as of now. So we need to wait till NVIDIA goes ahead and releases that. The CUDA compiler and libraries, if you want to really go ahead and install the latest version, this is how you need to run it. NVCC was earlier, you would be able to run it, but in the recent NVIDIA SD card image, which you see that this particular tool has to be enabled, or the modules has to be loaded. Now, this is interesting, but how shall I build those apps from the scratch, right? And this is where your generic Docker workflow comes into the picture. So if you look at the Docker, so usually the workflow is build, ship, and run. As a developer, you sit on your laptop, you build some application, push it to the Docker hub, and that get pushed. That can be pulled by your customer to go ahead and run it, right? So think of it, for example, the Hello World example. Docker run Hello World, and it runs really great because this particular Docker image is right there on the Docker hub. And the reason why it is working on your x86 hardware is if you run M platform mquery Docker image, you will see that it supports Linux AMD 64. And that is the reason this is basically a Docker image which you can use on any of the image which you are trying to build, whether it supports this platform or not. But think of a scenario where you, as a developer, sitting on your laptop, building an application, and then try to deploy it on the edge device. That is not going to work. The reason being, this particular image has not built for the ARM devices, the ARM architecture. And in the same way, if you try to run Hello World, the Hello World is able to run on those Jetson devices. The reason being, if you go and try to run M platform mquery on the Hello World, you will see that the Hello World image, Docker image, which is like quite a popular Docker image, has been built on all this platform, AMD, ARM, V7, V8. These are like a different architecture. So think of it as like the Raspberry Pi. It comes with the V7 and V8. So V8 is for the Jetson Nano. So they are different architecture, the ARM architecture built for the certain specific hardware. And the reason why it is working, because it supports all those platforms. Even it runs on Windows, because if you see here, we have Windows AMD 64. Now, the question would be, do I need an ARM devices to build ARM-based images? Not necessarily. Sitting on your Apple MacBook, you can build the ARM images, and the answer is BuildX. Now, BuildX is a CLI plugin which helps you to build a multi-architecture Docker images. So if you look at the command Docker BuildX build, and you specify the platform as ARM V7, V8, and it is going to go ahead and build those kind of images. So sitting on your laptop, you build that image, and then that can be pushed to your IoT edge device. Think of it as like when we are talking about the cloud native application, like any developer who is building an application doesn't have to be on Raspberry Pi, or you don't have to go to the cloud and bring up all those architecture to build up this application, right? So whether on your laptop or in a cloud, you can use the same Docker BuildX command to build those images and then push it to all your edge devices. Now let's move to the next topic, which is K3s. Definitely K3s is a lightweight Kubernetes which you run on IoT edge device. The reason being, If you run a full-fledged Kubernetes distribution, it is going to be heavy for the IoT device because of the less resources. We don't need to install a gigs and gigs of different application related or different Kubernetes tools. So K3 is a fully compliant certified Kubernetes distribution. It is really easy to install. So you can see here, you just have to use the curl command, get k3s.io, and then use the sh command, and it's done. And when you add a worker node, you just have to give the token. You have to supply the token to it. That's it. Today, so K3s works with a different backend storage like etcd, MySQL, Postgres. It works. It has been well tested. And the interesting fact is the complete binary is less than 100 MB, right? So it's quite less, especially when you have an SD card image of around 64 GB or 128 GB, and if you want to run a heavy workload, right? Even the NVIDIA, most of the images you see, the deep streaming and all this thing, they are like a gigs and gigs, right? So in that case, when you have an orchestration engine running on your Jetson Nano, which is less than 100 MB, it matters a lot. Now, the most important thing which you really need to understand that K3s support both Docker and Containerd. Okay, so this is really important. So you might see a few of the blogs which have been written primarily on the Containerd or Docker, but right now you can plug and play. And in this one of the example, a screenshot which I'm going to show you, it shows you like how you use the pods with Containerd as well as the Docker. So if you want to run a device query, okay, device query is again a kind of a CLI which queries the device, whether the GPU is available or not, and all this thing. So running a device query on Docker with GPU support, you have to go ahead, use this Docker file. So what has an NVIDIA done to the SD card image is when you flash the SD card image, there is a directory under temp samples utilities. So starting from 1 to 5, there are different utilities. So device query is one utility, and all you have to do is go ahead and they say put it in a Docker file and try to build it. So if you see here, Ajit Raina /Jetson _device query is a Docker image, and you can specify the Docker file. And once you do that, all you have to do is say Docker run and supply the runtime as NVIDIA. Either if you have already passed that variable into your daemon.json, then you don't really have to do it. But I would recommend to go ahead and pass runtime NVIDIA, so that you can expect the right results. So once you run this, it basically find out the devices. So here the device 0, so we have the GPU device. It has identified as NVIDIA Tegra X1. Now the same thing if you want to do with the Containerd. So this is how it looks like you can create a bash script and you have a CTR rather than using the Docker command, right? So you can use a Containerd to go ahead and you can specify the GPU's 0, right? It has been tested. It has, so Containerd today identifies the GPU. So you can do that. And now the next part would be how to run this device query as a pod on K3's cluster. And this is how it looks like. So this is a YAML file where you specify the metadata as device query. You specify the container information. The name of the container is NVIDIA, the image, whatever we built in our last slide. I'm going to do that and then just run device query. And all you have to do is, if you have a K3s, you just say kubectl apply, and it's done. And this is how it looks like, where I'm just describing the pod of the device query. Now, let us look at the real-time implementation examples where the Docker and K3s has been used. So one of the interesting example which I can look into it is, I have been working as a smart camera system building it. So if you look at the Jetson Nano device itself, we have 3 major component parts. One is sensors, one is GPU, and one is a camera module. And how you are going to all these 3 components can be accessed using a Docker or Containerd, right? So this is a smart camera system for real-time crowd mask detection. In the COVID situation, definitely think of it as like you are a mall owner where a lot of people are coming in, and you just want to track like how many people are really wearing the mask, right? So this is one of the use cases which I took. So the mask detecting system, what do you need? You need a Jetson Nano board and a camera module, right? It could be a USB camera, or it could be just like a file which you can pass to the basically Docker container. So if you see here a Jetson Nano dev kit, which you need a Jetpack 441. You have a power supply, you have a USB webcam has been used, and then another computer which basically has access to the VLC. So it get exposed to the certain port like 8554. So if you have a Jetson Nano, you flash the SD card image, and all you have to do is connect your camera and run this command: Docker run runtime NVIDIA privileged. So right now you can also, there are certain Linux capabilities, kernel capabilities, you can use the capabilities to here. And then you pass an environmental variable where you pass the Jetson IP address, and you can even run it from your laptop itself, right? And then there are certain ports which have been exposed. And once you run this, then most probably this is something, you let me show you one example here. So this example shows you that it's a Dubai mall, and the people are passing in, and I'm just trying to track the wearing the mask. So I have passed a file instead of the camera here. Okay, and the interesting fact is it will track how many people are really wearing the mask or not. Just with one Docker container, this application is running on Jetson with a camera module connected. And the interesting fact is it is calculating how many unique people are wearing the mask itself. And if it is not visible, it says not visible. So it's all about AI. It's all about IoT edge device. It's all about bringing the container native, cloud native technology like Docker. And the same has been tested with K3s when you run it as a pod. The same image which you can use it either with a containerd or with a Docker. Now with this, I am going to introduce one of the really interesting stuff which I am working on, which is called as a cherry bot. So this is the first time I'm talking about it in an open meetup. And this is one of the effort which I started around 6 months back with one of the Python developer. And this is work in progress. So right now, so the whole idea of this robotic platform is basically the different use cases. So it's an AI-powered payload delivery system, which is a low-cost autonomous robot system. It has a Jetson Nano, it has a digital face, it has the GPS module with the camera, the LiDAR sensors. Now, you might be saying like there are so many other bots which are available over the market. Why this? The reason being, all of this application, the first thing is all of this application which will be running for this to control this particular robot will be a containerized application. The second thing, it uses a Jetson Nano, which costs just like $59. So the primarily what it is going to do, it will basically be equipped with the Jetson Nano board, low cost, low powered AI deployed as an edge device. It will be using a deep learning for sure to correctly interpret the data gathered, and then it can identify your objects. So this is just to give you a glimpse. So we are starting with something from the scratch. We are heavily using RoboMaster for our baseline, where you have a 4 wheels, and on top of it, we are going to put kind of using a 3D printer. The idea is to get in a compartment over it, and then the Jetson Nano, 2 of the Jetson Nano with 6 cameras. So the whole idea is, so right now we have tested the deep learning platform with it, trying to identify the objects, but there's still a lot of work to be done. Primarily, the use case would be the food delivery, swag distribution, and medicine delivery. So think of it as like you are in a university where you want to parcel a food and within the premises. So the cherry bot is going to deliver the food for you. If you are in a conference and you want to distribute the swag, so cherry bot is going to help you in distributing the swag. And think of it as like when you have a touchless medicine delivery system within your apartment or in a hospital. So the cherry bot will be the one robotic AI or AI powered robotic platform which is going to hand over those medicines to the patients, right? And if you are really interested, I have submitted a CFP for ARM Dev Summit, which is happening in October. So as part of an ARM innovator, the plan is to go ahead and display this product. So there is still a lot of time to go ahead and work on it. And if you are really interested, do reach out to the Collabnix Slack channel. I'm open to collaborate with it, even though there are a few other parts. So during trying to build this kind of infrastructure, it always requires, there are a few other parts, the IoT parts, which you have to get it from China or Dubai. But it has been a challenge because of the COVID reasons and all. But I'm happy that we are back into the action, and definitely maybe in our upcoming meetup, I am going to talk about full end-to-end, solution, like how we build this interesting AI-enabled robotic platform. So with this, I think I finished before the time. So let me jump back and try to see if we have any question. Ari, are you there? Okay. Yeah.
Yes, I am. Well, you know what? I did not. I think people were so focused on the interesting topic that you spoke about that honestly, the chat has been silent. But I think it was out of amazement at some of the things you shared. But if anybody now has some questions they'd like to ask, now would be the time to drop it in the chat.
So meanwhile, let me look at the chat. So I don't see any of the questions.
Well, what I could do while we're waiting, just to make sure that nobody has any, is I can go ahead and just share the announcement that I shared in the beginning about the raffle. Is that a good timing for that?
Yep.
Okay, great. We'll do that really quick and give people a chance to see if they're formulating any questions. I'm looking forward to one day having a cherry bot hand me swag at a conference. That looks really, really cool. But I just went ahead and shared my screen. I'm not sure if you can bring that screen up. And for the meetup that we have today, we want to provide a chance for you to enter a raffle for a chance to win a JFrog t-shirt and a liquid software combo. It's the t-shirt that you see most of us wearing today under our cameras. And it's our JFrog annual t-shirt, which is really, really awesome. And of course, JFrog is a liquid software company. So that is explained really, really well in this book written by two of our founders, as well as others within JFrog. So we're very excited to give an opportunity for you to enter the raffle. We don't do live drawings, but we're going to give about 50 of these out. And we would encourage you to enter. And there you go. Thanks, Ajit. Enter, and you will have the opportunity. We'll contact the winner. We'll select winners within 2 days and contact them via email if they've won. So with that, I'll turn it back over to you, Ajit, to see if there's any questions, and also maybe to introduce our next speaker.
Okay. So let me see if there is any question. Okay, so I don't see any other question. So one of the feedback from Suman is looking, okay, containers enabled on edge is a nice use case. Okay, yeah, definitely. Definitely there has been a lot of things which is happening around K3s. And maybe in the near future, I will come up with more and more in depth into the experiment which I have been doing with all those things. So moving next. So maybe we can, I'm just checking in internally how it looks like. So we have the next speaker, Sujay.
Hey, Ajit.
Sujay, can you hear us?
Yeah, I can hear you. How about you hearing me?
Okay, just give me a few minutes time till I just bring up a few of the stuff here. So by the way, how are you feeling today?
Great, man. I was eagerly waiting for the session. Cool sessions went ahead before me, especially Melissa's session. Revising all those Docker history was great. and listening about
Okay.
you on the IPH. That was great. And something new,
Okay.
DevSecOps. It's something new to me.
Yeah, that's true. Sujay, can you go ahead and share your screen? Meanwhile, I will just
Sure.
introduce and I will get you added. Okay,
Yeah.
so talking about our next speaker, we have Sujay, who is a Docker captain and certified Azure cloud engineer at Zevil, joining us from Penang, Malaysia. So Sujay has around 10 plus years of experience in IT field, where he made that transition from managing a large data center from physical server to working in the cloud. And today he is here sharing with us his expertise on implementing a landing zone in Azure using Docker containers. So let me add you. Okay, over to you, Sujay.
Yeah. Can you confirm? Do you see my screen?
Yeah, we can see your screen.
It's on full screen mode, right?
Yeah.
Okay. Yeah. Good morning, everyone. My name is Sujay Pillai. I'm based out of Penang, a small state in Malaysia, and I work as a cloud engineer for a company called Jetson over here. And I'm also a Docker captain and a Docker community leader, where I run the Docker Penang Meetup group, also the Kubernetes Penang Meetup group. First of all, I would like to thank Docker Bangalore Meetup Collabnix community and the JFrog to support these kind of events and having me on the list as a speaker. So the topic what we are going to listen for the next half an hour is called Rover. Basically, I'm going to introduce you to a tool which is currently being in development. It's very new, which helps you to get started with your cloud journey, especially in Azure. So we're going to cover most of the topics around it and how we can leverage that in a Docker container. So basically, the agenda for the session would be like talk about basic things about Azure Cloud Adoption Framework, understanding what is a landing zone, and the tool which I just spoke about, like the Rover, what it is, and how it can help us to build our landing zones, especially in Azure, which you can then go and adapt to your cloud provider also if needed. And we will go through a small demo around it. So let's get started. And before we start having into the topic, let's have a basic understanding about what is the Microsoft Cloud Adoption Framework, especially for Azure. So let's say if you are new to cloud and starting your cloud journey, you would have to think of many things like defining your roadmap and then articulate your visions to the business and get approval from them. There are many other things to consider about, like your existing infrastructure, the governance piece, how the security model would be when you move to the cloud, what should be your operating model, what kind of workloads you need to migrate to the cloud. And also there is a piece of cost associated with it. So you need to do all this analysis before you start the journey. So Microsoft has been working with many of their customers, and they found few certain challenges these customers encounter while they are adopting the cloud in their organization. And some of these challenges, main three challenges are, the first is the justifying the business use case. So how would you justify the business and make sure that they are ready to your plans to move some of the workloads to the cloud and start your cloud journey? So that's one of the things. And then the second thing is technical depth, which if I have to explain, like we may have some legacy applications which are running in our infrastructure. These are not updated to the latest and the greatest technologies. So moving these to the cloud may be a daunting task. Or maybe the developers or the person who used to work on this application have already left the organization. So you are very scared touching these kind of applications moving to the cloud. So that's kind of a technical debt area. And the most important thing is the skills, adapting to all these new technologies as they come up, especially in the clouds. Your people have to be trained very well, getting understanding how a particular piece of technology gets adopted into the cloud. So these are kind of basic challenges. So Microsoft, what has done is that they went down, and after working with most of their customers, they put down a nice set of documentation around the best practices, what technical guidance should be there for the people, and the tools that should be used to move such kind of workloads into the cloud. So that's basically the Microsoft Cloud Adoption Framework for Azure is. So in a simple terms, it's just the best practices, what they have learned from their customers, and they have well-defined documentation around it. So if you look on the screen, your cloud journey when you start with cloud may look like from left to right. So basically you start with defining a strategy where you document all your motivations and use cases, and after your business justification, kind of try to plan to move to the cloud. And the first phase is like, so basically plan, ready, and adopt are the miniature 3 phases when you start to move to the cloud. And in the plan phase, that's where you kind of align your actionable cloud adoption plan, understand what needs to be migrated, what kind of application needs to be taken into the cloud. And this is where you analyze your technical depth and everything. And after analyzing that, you kind of prepare your people to adapt to this kind of technologies, give kind of some trainings, and then kind of define a process and environment which would help you to get started with cloud. And once you are have this plan, second phase is ready, where you deploy your get ready with your Azure subscriptions and everything, setting up the environment, the best practices for the validations, and set up a kind of a blueprint or the first landing zone, which basically helps you to start your journey. And then you slowly migrate your workloads into this environment. And basically, all these pieces, what you see, also have a set of governance and manage thing associated with it. So where in the governance piece, you define who should act, what kind of access should be given, what security baselines should be set for this cloud environment, what you have set up. And then that's how you basically get started with your journey into the cloud. And if I have to speak specifically about landing zone, so a landing zone hence can be defined. So if you switch back, we will be just concentrating on this part, how to define your landing zone, which would help you to get started with. So basically, if you had to define landing zone, it would be kind of a set of rules and configurations which helps you to bootstrap your first cloud environment. And basically, it's kind of setting up the identity and access management, the auditing and logging piece, what is associated with it, various compliance regulations, the security and the monitoring piece, and then the networking and baseline infrastructure, what you need to lay down to start your cloud journey. So in short, if I had to explain you in simple terms, it would be like setting up all the infrastructure components that that's needed to deploy your application into the cloud. So that's basically called a landing zone. And we all know that we can leverage infrastructure as a code, because doing all these activities, what I just said, manually is very daunting task, and there is like chances of error doing this on a repeatable fashion. So that's where we can leverage the infrastructure as a code methodology, where which would help us to set up environments in the fastest mean possible ways, and thus removing the human element part in that. And thus, this would also help to set up more environment visibility and improve the developer efficiency. So by adapting to the infrastructure as a code piece, you can store your infrastructure definition alongside with your application code also. And one such tool, what we already know, is Terraform. So that's where Microsoft went ahead and adopted Terraform in the cloud adoption framework. So there is a set of tools which is provided by Microsoft for deploying your landing zones, and that basically at the back end uses Terraforms. So if you go into the Microsoft website, what I've linked over here, you can see that the landing zone on Terraform is basically composed of 4 different pieces together. The first piece is set of Terraform landing zone, which is basically they have pre-built a set of Terraform files, which helps you to deploy your infrastructure. And these are combined into as a module. So they develop their own Terraform modules, and they also have pushed those modules onto the Terraform registry, where you can pull it down as needed. And specifically, we will be talking mostly on this last piece, which is called Rover, which is basically a Docker container provided by Microsoft to do all this deployment. So the Rover is basically a Docker container, which is basically a wrapper on Terraform, and you can kind of make use of Rover to deploy the landing zones in your infrastructure. So basically the advantage is that when it is a Docker container, maybe if you are working on a Windows machine or a Mac or Linux, you just have to have Docker installation and you run the tool. It's going to work the same way across all different platforms. And the second advantage is that it has basic integration with Visual Studio Code and GitHub code spaces. So that's where I'm going to show you how it is integrated with Visual Studio Code. And if you go to the Docker Hub, you can see there are 2 different images available for this. One is a standalone Rover binary itself, which is basically the piece of software which helps you to deploy the landing zone in your Azure infrastructure. And then if you have to adopt this into your DevOps pipeline, there is also a Rover agent which you can integrate and basically call into your Azure DevOps pipeline or maybe other CI/CD tools like Jenkins, etc. So that's basically about Rover. So let's jump into a demo over here. So what I will do is I will switch to my terminal. Let me get out of this. I hope the fonts are clear to everyone for the demo. And if you have to visit the GitHub page for this, this is the website where you can find all these pieces. So, and this is where I talked about the 4 different modules. So basically the repository is divided into these projects, and we are specifically concentrating on Rover over here. So what I did is that I went ahead and cloned this starter kit project, which is basically bootstrapping, kind of an example for you to bootstrap something into Azure. And so I have already cloned that into my machine. And if you do Docker ps command, you would see that there is no Docker container running right now in my machine. So what I'm going to do is that just open up this code base into Visual Studio Code. And as soon as I do that, you'll see my Visual Studio Code popping up. And if you see on the left-hand side of the navigation, you see a dev container folder. So basically, this is where the Visual Studio Code knows that if the project has to run in a Docker container, I can leverage this dev container folder. And with help of this Docker Compose file, what it does is that at the backend spins up a container for me. It's basically right now at the backend activating the container for me, and you see there is a pop-up folder contains a dev container configuration file. Do you want to reopen this to develop in a container? So when I click on this one, reopen in a container, and you would quickly see that my machine would spin up a Docker container for me soon. Just give me some time. So the Visual Studio is basically kind of loading at the backend, and you should soon see a Docker container popping up over here, which would again, basically what it will do is that it will kind of spin up the whole, the starter kit project, what you're seeing over here in a Visual Studio Code, and that will be running in a Docker container for me. It's kind of stuck over here. So basically what we are going to do is that this is my Azure subscription where you see just few resource groups deployed right now. But using this starter kit project, I'm going to deploy few of the resource group and Azure resources, which is kind of a base start point for my cloud journey. It's kind of stuck. Let me try to restart it. So how the things work at the backend is that there is an extension from Microsoft, which is called the remote extensions, which helps you to do all your development in a Docker container. I don't know, the code is behaving weird for me. So if you see the first extension, what is listed, remote containers, that's which enables all this capability of doing your development in a Docker container. I'm having a hard time to load it. Let's see. If you go to your command palette, you can do this one also, remote. So this is the other option you can do to load that in a container. I think it's down downloading something. Let me just finish that one. So Ajit, while that gets loaded, I can just take up some questions if there are.
Okay, fine. No problem. So one question is like how to connect Azure from your laptop.
Okay, so I can show it on a terminal. Right now, if you do AZ login command, it would pop up. I'm not going to do that right now. I have already logged in for the purpose. That's how you do a login. So it will take you to your Azure subscription and do all the authentication and give back a token to you, which is basically there on your machine. And if I do a AZ account show, you can see that I've already logged into my machine.
Okay.
So that's how you get logged into the Azure on your machine from CLI and as well as in the dev container also.
Okay, so in the same way, there is one question about: is there any PuTTY software which is needed for that, for connecting Azure from your laptop?
No. That's basically the PuTTY would be needed if you are trying to SSH into a box. This is like you are interacting with your Azure subscription through the CLI. So in that case, you don't need any PuTTY software.
Okay.
So I see another question, can we customize the resource that will be deployed by Rover? Yes, definitely. So if you see on the file explorer, what I have, I don't know why that is kind of small on the live stream, the Visual Studio Code. Do you see a full screen of it, or it's a?
No, it's a small screen. Maybe I think when we are going ahead and playing the slideshow, it shows the full screen. But let me try from my end if it works. So right now, it's a bit better.
So basically, let me switch to the code repository. So the code repository which I showed you earlier, it has so this one, if you see on the screen, this has a set of Terraform files configuration. If you go down into this and open up the demo, each level in this has different Terraform configuration files. So you can go and customize this as per your requirement and adopt it to whatever you want to deploy in your specific Azure subscription. So that's how you do configurations as per your requirement.
So we have another question. If possible, can you show us how a workload is getting created and show the Rover process?
Yes, that was what I was trying to. Okay, do you see the screen now?
So we do see a kind of a Visual Studio.
Yeah, but it's not what I wanted to show you. It's not coming up. Let me try to do.
Okay. So you are not right now. You are just your slide is not you are not into the slideshow show mode, right?
No, I have queued that slideshow mode.
Okay.
Maybe I can kill that because I don't have anything to show right now. Let me try to quit the output.
Can you go to the view and see if we can make the changes? What did it show?
Or let me try to stop the screen share and come back.
Okay. And let us try it again and see if it works. Yeah, now it works.
Okay,
Great.
great, perfect. So this is what I wanted to show you. So basically what I did is that I went ahead, opened my Visual Studio Code by doing this code dot, that is opening up the current project. And earlier I showed that there was no Docker container running on my machine. But if you see right now, I have a Docker container which came up. That is because I'm running this whole Visual Studio Code in a Docker container. So that's the reason you see. And if I bring up the terminal over here, you would see that I'm landed into a Docker container, which is, if you see the ID, that would match with my Docker container ID, which is over here. So that's how basically you load your Rover environment. So basically you are not loading your Rover environment, you're loading the landing zones, what you want to work with in a Docker container. And in the container itself, you can see I have a tool called Rover. It's hard stuff.
Yeah, Sujay, can you hear us?
Yeah, I can hear you. I'm just stuck with the screen over here. So
Okay.
I basically, let me try with another terminal.
Mm-hmm.
So how this project knows that I need to load this in a Docker container is through this Docker compose file. So you see I'm specifying a specific Docker image from the Docker Hub, which I mentioned earlier, and using it as a different user. So and there are certain volumes which loads all your Terraform files into this container, and then it's basically giving you all the access to the Terraform configuration files what you have on your machines. I don't know why. Let me try to open once again, Ajit. Sorry for this.
No problem. Maybe Sujay,
It's
since we
gone
have
again.
less time, yeah, I think it is
Okay.
not
So,
displayed completely. Maybe you can explain, if you can explain in words, so
yes,
that.
yes, yeah. Let me do that. Let me do that. So
Yeah.
basically, people can understand. So once you are, let me try to share again so that it resolves.
Okay.
So what I want to do basically in the demo is once you are into the Docker container, I would specifically pull down a landing zone, which is basically a template given by Microsoft itself, into my project repository. And then I wanted to just spin up some environment in my Azure subscription. So I would define some environment variables. And basically, I said that Rover is just a wrapper on top of Terraform. So if you see the basic commands, when we execute Terraform, we basically do a plan, Terraform apply, and then Terraform destroy to basically kill down all these resources what we have spinned up. So basically, it's the same kind of step. It's just that we need, with this tool, Rover, we need to provide what landing zone we are using to start with. And then into that, we are passing to the Docker container, saying that please use all the files from this, where my Terraform scripts are. And then if you have specific variables which needs to be defined according to your environment, so that's where you define into a specific folder and the kind of parallelism you want Terraform to execute with. And these levels are basically, if you go into the documentation, you can see that there are different levels of Terraform projects which are associated in the project hierarchy for landing zone. So level 0 is basically starting with the base setup of your subscriptions and other things which you need to get started. So I already have a subscription and I wanted to deploy something into it. So what I will do is that I just execute this command over here. So once that's done, you would basically see a few deployments happening on your site. And after you do a plan, it will say that I'm going to deploy all this set of resources into your Azure subscription. So all you need to do is that after that, just change the command into apply. And that's where it will do all the deployment for you. And after a few times, you would definitely see some Azure resources spinning up over here. I had deleted my previous environment, else I would have shown how it would have looked like. But that's how the deployment with Rover would get executed.
Okay. So Siogi, do you want to take the last question over the screen?
Can we say CF is helping to create the architecture runway in safe? So yes, if you see this Rover environment is running in a basic Docker container. So any developer who just need to start with Rover just need to pull down the image or this code repository, and it's giving you a full-fledged environment where you can start with the development activities. And staying within in that container, it gives you that kind of security boundary to work with it. And there is another this agent which you can pump into your DevOps pipeline, which would help you to deploy your infrastructure. So all those security pieces are there, which basically helps you to do the deployment.
Okay. Okay,
I'm
Sujay.
very sorry, Ajit, I couldn't do a demo fully, but if I can do is that I can record a video and share it with the community later.
Yeah, sure. That would be really great. And by the way, like especially in the Collabnix Slack, we can upload your slides so that if there is any question, we can take it up.
Yeah, sure.
Okay,
yeah,
Sujay. Thanks a lot for your time.
Yeah, thank you, Ajit. Thank you, community.
Thank you. Bye. Okay, so we have our next speaker, Suman. So Suman is right here. So Suman, how are you doing today?
Yeah, I'm doing fine, Ajit. Thanks for inviting me for this meetup. It's really informative. I was just following up all the sessions since morning, and they are very informative, right from the Docker history. Then your session was very good, actually. I mean, got to know many things around our IoT, and Sujay session also. So yeah, looking forward for my talk also at the same time.
Yeah, thanks, Suman, for your time, and just let the audience know that Suman has been there consistently as a speaker from last like 1.5 year, more than 1.5 years. I do remember we did a session in SAP Labs
Yes.
where there were around 500 plus people. So it was a great session, right?
Yeah, it was
So,
a good.
so let me go ahead and introduce you, and then most probably you can start with the session. So,
Sure.
for anyone who is new to Suman, Suman is a senior DevOps engineer at SAP Labs India. On a day-to-day basis, he manages DevOps for SAP ABIP on Cloud Foundry and Kubernetes platform. He is a microblogger and very involved in the community as a speaker at Collabnix as well as Cloud Native and Data Management Group. So he's here to talk a lot and lot more about the container security. So let me go ahead and add you, Suman. Suman, can you share your screen? Okay. Yep. You can
Yeah,
directly go to your slides.
sure. So is it visible?
Yep.
Okay. So thank you, Ajit, for the introduction, and hello, community people. It's great to see you on a weekend. Weekend, but I think the session that I'll be giving would be helpful for those who are new to the containers, and probably for those who are thinking of how to implement security within the container ecosystem, not only with Docker, Kubernetes, but as a whole on a greater ecosystem for development of their applications, that may be microservices or any such other services that are built on containers. So yeah, so as Ajit already gave a brief introduction, so now I'll just go through quickly. So I'm working as a senior DevOps engineer with SAP Labs. I have been a speaker in various international tech conferences with Open Source Summit from Linux Foundation, Hashi Talks, and with DevOps India Summit. I have been community member and speaker with Collabnix for quite a long time, and I have given and I have shared my experiences, my learnings on different technologies with Docker and Kubernetes with the community at large. And I'm also like a micro blogger, and I do post articles on various technologies related to the PaaS, cloud native, and serverless. And when I'm not in my work, I would rather like to travel, and a big foodie by nature. So, okay, so let's go to the agenda. So the agenda for today is to start with understanding what container security threat looks like from a recent analysis, and then looking into the threat model, the vectors, the objects which are mainly responsible for bringing this security aspect within the containers, and then understanding the runtime security that is looming overall for all the container based deployments, understanding some of the common threats and risk, how we can basically overcome these threats by adopting certain best principles, and then going through a bit on the tools and technology that can help people like us, like the developers, the DevOps, to basically mitigate this issues, and a quick demo on some of the tools. So to start with, StackRox, a company, a leading security company, which was recently acquired by Red Hat, has conducted a survey in the last year in between the users and the end companies to understand that what is the level of security mishap that the company or the as an end user experiences, and what are the common pitfalls. So from that result, what has been picked up is that almost like 67% attributed to misconfiguration of your application containers that are running in your environment. Some of like 22% was basically attributed to certain major vulnerability that got introduced within the software itself, like the container image that is pulled from the particular registry, and then 17% was mainly attributed during the runtime. So the runtime is a crucial part here, because most of the containers life cycle stays within that runtime. So anything that is happening there gets directly or impacts the end applications. And some of them, around 16% was where there was the auditing which got failed because of the issues which were not being followed as per the best practices laid by some of the common standards like the CIS benchmark. We'll discuss this in the next slides. Just I want to give you a very brief overview. And 10% there was no response. So overall, I can see there is a certain level of security that is always there, whether you are running your application standalone on an environment, or you are running in a DevOps pipeline. So that's why maybe the term DevSecOps is gaining more traction these days, because the aim here is to mitigate these issues as early as possible before they actually land up in your production environment or to your customer environment. So OSP, which is Open Web Application Security project, is it's a non profit standard based community driven project, which has published a threat model on these containers that basically define different parameters from where, I mean, this from where we can experience some sort of threat from unknown persons or an attackers, if I say. So some of them were, first of all, if I list out point wise, so first thing was around the kernel exploit. So what happens in the kernel exploit, like if your container starts panicking, then what it does, it can overall exploit, or it can bring down the overall host system where it is running, because since the containers in nature share the kernel resources such as C groups or namespaces, then certain parameters, if doesn't go well on the container level, can get boiled down at the host level, thus bringing down the host system. Then there was another parameter called as denial of service that happened across the network file system on your resources, where it was seen that if a compromised container, so in general the containers share resources from the kernel space, user space itself. Now if one of the containers gets compromised, then it can basically fully utilize the resources and starve out other containers. So this may leads to, again, misutilization of the containers, and also it can basically create an attack chain within the host system. The third thing was around the network. So network plays a very key role, because we know that in any, like whenever we talk about operating an application in a cloud environment, there are different network segments, whether it's your private network or public network, which basically gives you certain access point for people, or for someone to get an access, or to get a path towards your application. So similarly here, on the network level, there can be a possibility that some of the ports which are meant to be public is not secured properly, like over a TLS site, like without having a mutual TLS between the service endpoints, or it can basically leads to an internal routing from one container to other container if they are not secured properly, or if the access is not given correctly to the container where it is meant to. So uh, coming from the network, the other part which got highlighted here is the container outbreak, which mostly happens in cases where you are running some of your images from your Docker registry, and you don't know whether the images which has been created in the registry are the actual image. I mean, that is not maligned some way. Let's say, for example, some of the like mostly we end up using certain image from the public workspace into our environment without knowing that what is the level of permission that has been set within that image. So it can be a flaw that is introduced manually, it can be a flaw that has been introduced unintentionally. So this is one of the area, while poison image mostly reflects to those containerized image where there can be suspected viruses, trojans that has been introduced and has been infected, or the images which has been outdated and still we are using that without a proper kernel patch. The last thing that was basically highlighted in the threat model was the secrets, or the, let's say we talk about the different secure informations. Let's say it can be an API, it can be password of a database that we are passing, and how we are passing that, it matters. Like normally the configuration should not be passed as an environment variable, rather it should be stored in certain vault or in a secret management solution and then access. But then it again boils down that how you are using a image. If you're using any public image which has basically created certain areas where the secrets can be compromised, then it will bring or basically compromise your entire operating system. So looking from the threat model, we now basically bring down the attack vectors from where we can imagine that your container can get compromised. Okay, so first thing is about the application code that as a developer you may develop, or the other developers may give you, which may contain certain loopholes or flaws which attackers can exploit, that can simply raise from basically improper user privilege to to using certain file or copy command without knowing from where you are basically copying the particular artifact. Second is the badly configured container image. So this mostly again relies that once you have built your image and you have pushed into the registry, but then your registry is uh, if you are basically pushing it in a public registry, and there is a chance that your image can be replaced another again with another image that may contain similar properties, but that has a different digital certificates or a verification key which may not match, and you may not know about it, and you can simply use it maybe into your CI/CD pipeline without scanning it first. So that where it refers that your container image gets compromised. The third is building the meshing attack. So a meshing attack is sometimes we refer as a brute force, where basically the attackers tries to influence the build of the container image by some way, by try to gaining access to the host operating system through certain, let's say it can be like there is a certain network port which has been open, and we are continuously or someone is continuously sending a ping request to get certain response and try to see which particular process is giving a response. So as we know that Docker runs as a process within a host system, so it may happen if you haven't secure your input, then the attacker can get us I mean he can sniff on the particular route and can get access to that, and that is by brute force he can get he can get the access of your entire host system or take down the entire host environment. Fourth is the exposed secrets, which I was already discussing, where the secrets or the informations related to your TLS certificates, related to your password credentials, related to your username passwords of your users that you are defining, should not be stored as plain text within your container image. Rather, you should use certain uh, vault secret manage. I mean, you should use certain secret management tool that is provided from some like third-party companies like HashiCorp has their vault, or you can use the Docker secret management as well to basically create it more, or basically encrypt the informations in while running it within the container. The next thing that is the insecure networking, which basically refers to the intra and the intercommunication pattern that happens between the containers that is running within the host machine, as well as when the containers is communicating with other containers that are running on a different host machines. So ideally in this case you need to have a very strong periphery or yeah, let's say you basically set up a very strong firewall connectivity or rules between your host machine, so that even your containers has certain way to reach to from outside the gateway of your host machine, that it should not lead to connect to other host machines. So networking becomes a very important factor here. Now, when we talk about the attack vectors, then mostly most of the security that comes boils down at the runtime level. So what container runtime security involves? So it basically gives you the, or basically helps a company or an individual to understand what are the potential threats that can affect your application, and how and what are the different ways to mitigate that. So when we actually talk about runtime security, it actually brings down implementing certain level of restrictions on the runtime. So it can be on the Docker side, you are using the Docker runtime, or you can use say other runtimes such as a Cryo, or let's say you are using Runc for instance, or even Containerd. But whatever runtime you use, the ultimate I mean the aim here, it should be that just not only to basically minimize the attack surface area, but there should be a considerable way of bringing restriction right from how you are basically monitoring the network endpoints to the payloads that it is going through the container, and then basically bringing down how you are able to communicate between two containers, that means the network. So all these three, when this combines, it breaks basically the chain vector which is responsible for bringing this attack right from the time the image is built to it is run. So there are different levels of attack that are there. So at the container level, it can be at the vulnerability side, there can be certain suspicious processes running, can be that some of your file system activity is unauthorized and you are able to so that's why the monitoring becomes very important in all the aspects, whether you are monitoring at the container, host, or the network level. Similarly, at the host level, there can be privilege escalation, or there can be if you are like managing your containers using certain orchestrators such as a Kubernetes, or let's say Docker Swarm, or it can be any other orchestrator tool, then you have to understand that you have to set or limit the blast radius of your controller, so that only the genuine request goes through and gets accepted at the place where the containers are getting scheduled. And then at the network level also, that involves different attack threats that can be coming from the inside as well as from the outside, that also can lead to certain DDoS attack or DNS attack, which we have mostly seen. The most concern here is to reduce the MITM attacks, or the man in the middle attack, as much as possible, so that we can basically secure our entire workflow of building the container from the build ship to the run state. Now, let us look into some of the common threats and risks which we have mostly observed while running containers inside an applications or while building microservices. First thing is about the image risk, which we have already discussed, that it leads certain image vulnerability, configuration defects, or there can be certain embedded virus or malwares that we don't know that we are using. Second is about the configuration risk, which mostly leads it's sometimes mostly driven manually, because sometimes we unlawfully gives more privilege than what it is needed for an application to run. So we have to ensure that we have minimal privileges for a container to run on the host system, thereby reducing the attack surface and giving less chance for an attackers to get access to the container level. The third is the orchestrated risk, which basically leads about securing your administrative level periphery. Basically, can lead to unauthorized access, and then there can be certain interconnected network traffic that we don't know, but it is happening, and we have to minimize them. And also, at certain level, we have to understand what is the workload we are running on our system, and what is the particular traffic that it requires. So based on that, we can basically open those ports or allow those processes only to run. The next thing is about the registry risk. Registry is basically refers where we have certain insecure connectivity to the registry that we're connecting. Let's say, for example, we have built our own private registry instead of using the Docker Hub registry or the or any secure registry, and then we don't know how we are, and we haven't basically secured it end to end. So in that case, basically this also give an access for the attacker who might get connected, or who might get thrown into your internal network, and from there he can reach to your registry from the public network inbound access. So there can be certain insufficient authorization and restrictions that can be imposed at the registry risk level. Host OS risk, which basically leads mostly to the attacks, the large attack that happen at the host level, that can be because of a compromised kernel at the host layer. It might be that the OS image that we are using are not patched properly, then that's why it can basically leads to more level of vulnerability and file system tampering. So we discuss about the threats and risk that greatly looms while running containers on the on an infrastructure. But then there are certain best practices which we can follow. First is understanding how we can keep our base system updated. So I've divided that into multiple segments so as to understand that in which level we can basically adopt which best practices. So for the Docker, host and kernel security is basically keeping your base system updated always. Use minimal concentric host system. So with minimal level package that it is needed, don't unnecessarily blot your container image with packages that is not needed by your application. And also we can basically impose certain access control policy in the form of seccomp, AppArmor, and AC Linux to provide more restriction at the kernel level. Then second, at the container resource abuse level, we can basically use the kernel resource properties such as C groups to limit how much resource we want to allocate to our containers. Then we can basically implement certain monitoring and alerting on the deploy containers so that we know that if there are a certain spike on the resources that is being used at the container level, it may be an indication that an attacker is trying to sniff your container. The third is the container image authenticity, where basically we ensure that whatever the images we are using has been digitally signed. I mean, only the signed images are allowed to use on your actual environment, whether you are using standalone or on a CI/CD platform. And basically, like you can use certain such as Docker registry for this purpose. And also, it is always mandatory that when you use image directly from your registry, you basically run a scan before you are actually implementing on your environment. The next is about container image vulnerabilities. Container image vulnerability is more about ensuring that your images are scanned at regular intervals to understand if there are any new flaws that are introduced and to patch them as regular as possible. Also, the vulnerability scanning tool that we'll be discussing just in few slides next also helps to understand that how we can improve the shift left process. So basically introducing security more at the earlier level in the DevOps area so that we can mitigate the chance of having a brutal attack from the attackers or our application getting compromised when it is basically launched in the production environment. Compromise secrets is where we should also ensure that we should not pass any sensitive information as an environment variable, rather use certain credentials or secret storage such as a key vault to store the images. And also definitely no, we should not store it in a container image in a registry. Container networking traffic is where we should always ensure that we are using a TLS connectivity end to end, preferably MTLS, so as to give a secure endpoint between two different services which are communicating. Also allowing that the intercommunication that is happening on a secure port, not on any port such as port 2375 that we are using. So when we talk about the container breakout, it is more referred to the file systems that we're using. We can improve our restriction here by adding more capabilities that is available from the Linux kernel as well. Then also monitoring certain mount points such as var and docsoc, where basically a socket file is bounded, and that is basically responsible for running the process to ensure that it is not compromised in a way and to give as less privilege as possible. Don't run this files using, we should not run it with a higher privilege so that anyone can execute that. So now when we talk about basically the vulnerability side, then there comes up there comes obviously a question then how we can remediate this vulnerability, because we simply cannot go and do manual actions. Yeah, definitely you don't have to do. So that's why we have a different set of tools available both at the open source and also at the enterprise level, which helps us to do this auditing, scanning, and signing in these three different steps. So these tools are just a few are in few number which are mentioned. There are more tools which are there which can basically help you, but these are some of the best popular tools which has been accepted in the community and also has been used mostly at the enterprise level as well. So for the auditing, the most useful tool that comes is from the Docker itself, which is the Docker benchmark that gives you it's a tool basically that helps you to run certain scripts in order to validate whether your containers is in tuned to the practices which is led by the Docker security benchmark, which is provided by the CIS standard, actually Center for Information Security and Standard. Docker is another tool which is developed open source that does the same way. It basically helps you to understand whether the images that you are running within your system are complied against the CIS benchmark tool. OpenSCAP is basically broadly it helps to define different policies and also set up different auditing requirements that you can follow, which is again aligning to the base security standards that basically helps you to ensure that your container environment is safe and secure. When it comes on the analysis scanning, there are a lot of tools in the place, like for example the Clear, which is basically a very good tool, which was actually provided or created by Core OS, and now it's completely open source. And basically this what it does is basically helps to check your containers images against a common vulnerability databases, which is fetched from multiple other databases as well. Similar to that, Trivy is also a tool which is from the AquaSec and the Aqua security team, and that basically helps you to understand the images that you are running onto your system contains any common vulnerabilities or not. So basically it will list all the vulnerabilities, and it will basically help you to ensure that what are the level of vulnerabilities that are present onto your image. Cilium is more at the network level. It's a great tool to analyze what is happening at your kernel level, more from the kernel space to the user space. It basically helps to troubleshoot the packet flow using the eBPF as the technology to do that. Sysdig also basically helps you to scan your container images that you are deploying and basically check out for any known vulnerabilities. Then there are tools like Anchor, which does also the same. To mention, like there are good amount of tools on the enterprise level, such as JFrog has their X-ray tool, which basically does the complete not only the vulnerability check but also checks across the compliance issues, and also it lays down the different policies that should be followed in ensuring that your image is safe and secure on your environment. Singh is also a great tool which recently got added with the Docker desktop version, and basically you can use the Docker scan here to understand the common vulnerabilities that are there in the image. Next, coming into the signing side is where we understand that how the image that you're using are, I mean, it is proper, or is there any vulnerabilities that are there. So Notary is one of the most popular tool here in this space that basically helps you to understand whether the image that you are pulling from the registry is digitally signed and can be used into environment. Similar to that, Docker has the image signing content trust, which basically gives you a possibility to sign your images in digital manner, ensuring that only the verified images are pulled and run into your environment. So okay, so enough of theory. I hope it was not so boring, but let's deep down into the demo and see some of the tools in action specifically. So I have a Docker environment here. I'm just running I'm latest version of the Docker, and just I want to show you how some of this tool helps us in basically understanding that how we can mitigate these attacks. So first I will take showing you what Docker bench does. So I have a gist. I will quickly copy that. So I've just created just to give some time, else I have to copy the entire thing. So I'll share this later in my slide deck about this gist. So the Docker bench security is, as I was telling, it's an auditing tool that basically tells you the containers that you are running, whether not only the containers. If I say, it basically scans your entire container ecosystem, right from the file system, right from the configurations, right from the permissions that are set, right from the host configuration, and it will basically list you that what are the warnings, or let's say what are the critical things that you should look forward. And what it does, it basically compares this against the CIS benchmark standard, which is already laid down. So it's basically just help you in running them quickly on your system. So let's say, for example, if I see here one issue is that I can see that ensure that daemon JSON file are set to 644 or more restrictive permission. Now every scan will basically give you a score. That score basically helps you to highlight that how secure is your environment. So the more you mitigate this issues, then the score increases. So let's say I just run 644 slash etc docker daemon JSON, because it complained here that it was not set to the permission. Sorry, it's var run docker.sock. Oh, sorry, it's docker. Okay, now let's say if I run the Docker security once more here, so definitely since I have done some changes into my system, thereby it will identify that okay, some of the security risk can be mitigated because some actions has been taken, and already it will list my score here to be something more. So checks is 105 and score is 9, and if I see here. Uh, Okay, so here it says that ensure that the Docker socket file is set to root Docker wrong permission for var and sock. So let me just change that also. Uh, okay, let me just see. Maybe some of the file settings is not there. Okay. Okay. Sorry, it has already passed, and I was looking into this. Set to 44. Okay, it passed already. Sorry, I was looking into setting that again because I just observed the previous setting. So anyway, that is fine. So this is how we basically look into the Docker security settings. So next thing, the next tool that I'm going to show you is about how we basically run or try to get a vulnerability understanding about our existing Docker image here. So in this case, I'll be using the Privy, and the beauty of this kind of tool is that every tool you can run as a container. So you don't need to really set it up in your environment. You can just run it just to get the vulnerability out. I mean the vulnerability understanding of the particular image, and that's it. You don't need to set up really on your environment. So if you see, I have basically used Trivy here, and here what I'm trying to do, I'm trying to scan the Python 3.4-alpine image, and it basically will list me all the known vulnerabilities, like which CV ID it is belonging to and what is the severity, if it is high or low. And it says that it is basically found in this particular version, but it is fixed in a higher version. So which basically leads us to understand that what version of that image we should use in our environment. So similar here is the tool called as Clear. So what Clears does for us, so Clears, I had already set it up here. 1 minute. Okay, I'll just set it up. So Clear basically helps you to do the same thing, but in this case, it basically look more for the uh, static databases. So let's say if I just need to run, sorry, clear the screen, and I just take the IP address here, 172.17.0.1. And what I will do, I'll just so before using that, what I have to do, I have to pull an image, because it always looks up into the image that has been pulled onto your system. So unlike like Trivy, it cannot directly communicate to the registry and pull, but if you have the images running in your environment, then it can very well list that. So if I just do a clear scanner, and then I have to just give the IP or where I'm running. So it's 172.17.0.1, and then I just give here Nginx. that I want to basically scan it. So what it does, it basically starts the scanning process, and it basically gives you the whole list of vulnerabilities. So clear is more more elaborative here. So if I just give with a more option, you would be able to understand what it is just doing. So yeah, here you can see that whenever it scans your entire image layers. So that's why it is able to get the vulnerabilities across every layers that is being created for your image, and there it basically gives you what are the current CV that is available with a good description also, like there is a particular flaw which is introduced here and that you should mitigate those. So these are some of the tools which basically helps you in gaining understanding, like how you should basically how you should basically uh, secure your container environment. I should not say more container, but your container ecosystem together, because it's not about just securing the containers, but more about securing at the host level as well. So some of the final thoughts, that security is very important here in this aspect, because we have seen that cybersecurity can lead to a damage on the reputation of an organization. It can introduce certain penalties, unwanted legal issues from the end user side. DevOps and security team has to work closely in a neat environment. That's why we have something called as the DevSecOps, so as to basically improve the security posture and accelerate the speed of how the applications are brought into the market. And security should be everyone's concerns. That should be one important thing to understand. It's not like the DevOps people only understanding security, but the developer don't understand. They have to understand, because they are actually responsible for building the application from the base source code, right? So the time has come to shift left, that is starting security as early as possible, to basically ensure that we detect misconfigurations right from the time it has been built. Identify and implement and the security guardrails to improve the quality assurance that is very much needed for QA perspective. And since we are managing more and more number of microservices, the security controls should not be manual, rather it should be more automated and API driven, just like a Docker bench that we are using, so that we don't have to go to an individual benchmark standard and go to a terminal and see which is not matching. There should be a tool that should automate the whole process. Some of the references that I've referred, that I use for my talk here. And thank you, and I'm open to questions now.
Wow, that was really awesome. Thank you so much. I'm looking at the chat, and I want to see, does anybody have any questions they'd like to propose to Suman? A lot of great information, and really appreciate the time you put into putting that together for us. Looking here, I noticed that you have a JFrog shirt that none of us have tonight.
Yeah, exactly.
Were you at Swamp Up? Were you at Swamp Up
Yes.
last year? Okay.
Yeah,
awesome. Yeah.
I got it from the.
That is definitely one of my
But
personal favorites.
this is yeah, it's also my favorite. I was about to say, actually, it reminds of Doctor Strange.
That's exactly what it was supposed to do. Absolutely. Dr. Strange Frog is what we like to refer to him internally. So that's really awesome, Suman. Thank you so much.
Thank you.
I know that your slides will be available, and perhaps also you can hang out in the chat for a little while in case anybody has any questions. You can feel free to answer it. And we really, again, appreciate you being part of this tonight.
Yeah, sure. Thanks, Harry.
Thank you. Thank you. Take care.
Thank you all for listening to this, and I'll be available in the chat. Feel free to post any questions if needed.
Awesome.
Thank you.
Thanks, Suman. Well, our next speaker this evening is Stephen Chin. He's the VP of Developer Relations at JFrog and is a well-known global conference speaker as well. He is the chair of the CD Foundation Governing Board and a member of the CNCF Governing Board as well, as an author of multiple books, especially in the Java development space. I had the personal privilege of calling Steve boss on a daily basis, and he truly is an amazing mentor for his team. So today, Steve's going to be talking about scaling DevOps to the edge. So looking forward to that. And without any further ado, I'm going to turn it over to you, Steve. Thanks for joining us.
Cool. Thanks very much for the very warm welcome, Ari. It's great that I'm able to speak at this event. It's actually been a while since I got to travel to India. So this is my virtual trip.
Awesome.
Okay, and what I'm going to talk today about is a little bit about taking DevOps all the way to the edge of your deployment. So how you can scale and efficiently distribute and deploy applications to different edge devices. So as Ari mentioned, I'm VP of Developer Relations at JFrog. You can catch me on Twitter at SteveOnJava. So feel free to reach out on Twitter if you want to say hi. And I think we've all been playing this game for a while with working from home. But somehow when the whole pandemic started, I imagined things would be very different. So I figured that we might be like vigilantes, kind of like this, roaming the freeways, trying to forage for food with our trusty dog. Actually, as it turns out, a lot of people got pets during the pandemic, myself included. But I got a cat instead of a dog, or my kids got a cat instead of a dog. So that was a little bit different. And the other big difference is I think a lot of us ended up with a setup which looks a lot more like this than something more more out there. So it's great, and I think it's awesome that as developers we're able to work from home and we can stay safe and productive while working remotely. And if anything, I think the situation has caused companies to realize that it's even more important to support remote workers and remote conferences like the one we're in. So I think it's made it much more accessible for getting technology across the world and to a much wider audience, and also create a bunch of opportunities for developers to do things. And if you're anything like me, you probably have increased the number of IoT devices in your house over the past year. Maybe you even have security cameras, or you have smart plugs, or smart heaters, or other IoT devices in your house. And this is in general a global trend which is occurring with the move to the edge, the move where you have lots of internet connected devices that need software updates and need to be supported. So according to Gartner and Statista, by the year 2020, so we're already there, 20.4 billion devices and 31 billion IoT devices will be online. So that's a lot of devices. And if you look at it, it's things like smartphones. So I think we all have smartphones. Actually, smartphones have taken over even computer usage. The amount of internet traffic produced by smartphones has exceeded the amount of internet traffic produced by desktop computers. Smart TVs, smart fridges, and smart cars. If you don't have a smart car, I think we're all kind of envious of folks who do have smart cars. And smart cars in particular is an area and an industry where people are really pushing forward and making huge advances. So according to the Volkswagen CEO, they expect the software to make up 90% of the auto industry innovation. So I think all of the different car manufacturers looking at software and software releases as the path forward. So this is one of the examples of an industry where they are pushing things to the edge. They are deploying to devices, and they're creating fleets of devices which are electrified, so electric cars, autonomous, shared, and connected. And this is everything from smart cars to smart trucks to smart farm equipment, and the sort of use cases which they need to be able to account for when you're looking at supporting global deployments of smart cars are things like autonomous driving, so the cars know how to navigate by themselves. Fleet management, so you can know exactly how many of different vehicles which you have out there, know when failures are going to occur, when you need to replace them. A lot of electric cars have very advanced battery technology, which they're constantly improving the software algorithms to improve the efficiency of them. different sensors, especially if you're doing autonomous driving, but also for farm equipment, so you can measure moisture, humidity, and different things to improve your yield. Navigation and infotainment for consumer devices, automotive AI, communication systems so that you can communicate to the devices even when they're remote, regulation, tracking. One of the big things is for shipping and other industries, they need to be able to make sure that they're carefully tracking where things are going and the path from farm to table of all the devices or all the cargo which they're carrying. So this is another big concern for companies which do trucking and shipping. Carbon footprint data so that you know how much you're offsetting or increasing your cost as a company. Safety and security, and shared vehicle enablement. So there's a lot of use cases for this. And by the year 2030, it's expected that the connected vehicle market is going to be a 14 billion ecosystem. So this is a huge market. It's expected there will be 146 million connected vehicles in the US alone, 470 globally, and 15% of the vehicles sold will be autonomous. 30 to 50% of vehicles sold will have an electric drivetrain, and shared vehicles will increase by 40%. You can already see this with things like the California legislation that mandates that all cars sold must be electric. I think it was by the year 2030. So they're even pushing this from a government and a regulation standpoint. Okay, so if you see this trend coming, where we're pushing to more edge devices, to more connected devices, how do we get software to all of these devices? How do we do software distribution to all of these devices? And if you look at it, there's a general physics problem with software distribution as you go to edge devices. So if you're used to working with cloud computers and data centers, and even on-prem data centers or other environments, typically you have very fat bandwidth. You have the ability to transfer large amounts of data, transfer large Docker images, and do rapid deployments. But as you push to the edge, the fire hose becomes more of a drip, because essentially what you're deploying to are devices on networks which are slow, which are less reliable, and which give you a lot of constraints. And besides the general network issues, which is improving with technologies like 5G, you also have the issue of the one-to-many problem, where you have a small number of servers deploying to a very, very large number of devices. So again, you're splitting your bandwidth and your ability to deploy quickly over a very large network of devices. So just breaking down this problem, the first problem is rapid development. So if you look at the speed of development and change, over 520 million new apps and services are going to be released by the year 2024. So with all of these applications and releases being produced, it requires that you have the ability to deploy quickly to the edge as well. The second big constraint is deployment frequency. So how quickly you're pushing devices or deployments to the edge. And over 60% of enterprises are deploying to prod daily or faster by the year 2025. So if you're still doing releases which are monthly or weekly or even a couple times a week, this is something which is required by security issues, zero-day exploits, and in general customer requirements for having faster delivery. That you'll be shipping software faster, you'll be shipping software more often, and therefore you'll be shipping a lot more releases. The third part of the problem is the explosion of infrastructure at the edge. And if you look at this, we have a lot more devices which are coming on, and over 50% of new infrastructure is going to be deployed at the edge by the year 2023. So this exponential growth in infrastructure basically forces having better solutions to the deployment problem. Okay, and the last part of the equation is compounded artifacts. And there's 7 million edge locations and over 38 billion things predicted by the year 2021. And this is continuing to rise exponentially. So as the number of devices continues to increase, this requires that we have better solutions for distributing artifacts. And if you look at who's consuming these artifacts, who's actually the recipient of the artifacts, you have a bunch of different folks who are the recipients. So one of them is just getting your internal repositories to developers. The second one is external repositories, so pushing artifacts which are going to be consumed by different companies or by consumers. And over 60% of the Global 2000 are going to have third-party developer ecosystems, generating 20% of the revenue. So exposing artifacts externally to other companies is also a big use case. And the biggest use case is now machines, where you need to now push your releases to the edge with runtime environments which support this edge distribution. And I think if today you're primarily deploying releases internally in your company to Kubernetes clusters, or possibly starting to deploy releases to partners and other ecosystems, this drive and push towards the edge will strain your current release bandwidth for doing distribution. Okay, and then some of the bottlenecks to consumption of releases are development teams. So basically your ability to quickly deploy and produce new releases. So if you're following an agile process, if you're doing things quickly, then you can more quickly release your software. Operations, so your ability to have cloud native environments set up to deploy quickly, to have a lot of automation on the side, on the DevOps area. So the fact that you're here at a conference talking about DevOps and security and how to improve the speed of agility will help you to deliver more quickly and achieve this scale. The third bottleneck is the runtime environment. So making sure that you actually have a global distribution network so you can quickly deploy. And then finally, getting things to the edge and all of the end users. So if you're scaling effectively, you can reduce your development productivity time and by increasing your cycle time. You can increase your release velocity, and that decreases your risk. You can do global distribution at scale, and you can also do better customer acquisition and retention by getting things to customers more quickly. So this helps solve the problem of scale for your company. And there's a few different ways which you can accelerate your distribution of releases to the edge. So one approach is to do distribution via edge nodes, where essentially you're standing up instances closer to the edge devices. And those edges are the ones that are going to be deploying to the edge devices rather than your main artifact repository. The second one is you can rely on content delivery networks. So using CDN distribution, you can increase your ability to deliver static artifacts. You can't be quite as smart about what you're delivering, but as long as the artifacts which you're delivering are static files, then this can also help to speed up delivery to a global network. And the last one, which is the most flexible, is peer-to-peer download. So this gives you the ability to not only to deploy to the edge devices, but to have geographically co-located nodes which are closer to your edge devices, where you can have peer-to-peer sharing and higher velocity to quickly distribute. So let's go back to the automotive use case and how you can set up an environment which is going to allow you to accomplish this use case to deploy to cars more quickly. So let's say you have your CI/CD system set up using a CI/CD system like Jenkins or JFrog pipelines. This would push releases into an artifact management system like JFrog Artifactory. And the JFrog platform also includes a distribution solution. And what distribution does is it allows you to push to Artifactory edge servers, to content delivery networks, and to hybrid environments. So this allows you to set up instances which are physically closer to the devices you're going to be deploying to achieve that scale by setting up multiple different edge nodes or content delivery network nodes, and then quickly push releases down to devices so that you can more effectively release and distribute. Now let's talk a little bit about how you could do the same thing with a peer-to-peer topology. So let's say instead you're deploying in a data center to a Kubernetes cluster. And one of the problems with deploying to large Kubernetes clusters is that especially for large Docker images, the Docker image push in the data center network actually competes with itself when you push it to multiple nodes simultaneously. And you see huge spikes in response time for pushing large images down. So you can do this with the same sort of setup, right? Using Artifactory for storing your releases. Artifactory acts as a container registry. You can check your security and compliance with JFrog X-Ray, and X-Ray will dig into container images, kind of peel the onion layers apart, and then do security scanning of those vulnerabilities, which are matched against hashes in our known vulnerability database. So it flags any known vulnerabilities. Then you push it to distribution, and then this goes out to a network of devices. Now, in this case, rather than it being pushed to each of the individual Kubernetes nodes individually, they're set up in a peer-to-peer configuration, and as it's being pushed, a la BitTorrent, they're sharing the information with each other. And what this does is this improves the reliability and the speed of the network. So this shows you the response time with peer-to-peer technology and without peer-to-peer technology. And you can see that if you're pushing a large set of data to a large set of nodes, then the network suffers a lot of degradation, even inside of a data center when you're pushing to a Kubernetes cluster, because you're competing with yourself on bandwidth within the network, and you're not getting efficient throughput through the network to get your releases pushed quickly. With the peer-to-peer technology, this evens it out because now all of the nodes are sharing data with each other. So this helps you to achieve kind of constant performance and have a much more robust implementation for pushing releases. So this is an example of how the peer-to-peer burst technology works. And you're breaking the responsibility of serving a package between Artifactory and the CDN. So it's being split between those two. The initial download served by Artifactory, and then it gets pushed to a content delivery network. Artifactory, the edge node, does the content resolution to figure out what the right package is and determine which artifacts need to be served. And then it's the CDN which actually serves the artifacts. You can configure the CDN by repository for which you're going to put in the content delivery network. And you can deploy this either with on-prem or on the cloud to quickly push out releases using this technology. And even for very large Docker images, which are 85 gigabytes or larger, this combination of CDN plus peer-to-peer on each pod communicating with each other gives you the best distribution performance possible. And one of the things which we just announced at the SwampUp conference, which just happened, is in addition to our peer-to-peer technologies and our edge nodes, we also have a new private distribution network, which makes this even easier to set up with a self-configuring mesh of peer-to-peer nodes. So that makes it even easier to achieve this scale with very lightweight peer-to-peer nodes. Okay, so putting this all together in terms of how the JFrog platform helps to solve the edge distribution use case. So everything upstream from source control, you can use your favorite Git system for. Do your builds with JFrog pipelines, push it into Artifactory for storage, do security scanning with X-Ray. You can also have a lot of visibility with mission control and oversight, and finally push it to production using distribution and edge nodes, which work on-prem, work multi-cloud, and also allow you to push to CDNs and take advantage of peer-to-peer technologies. Okay, so the bottom line is you can achieve faster downloads, improve developer productivity, faster time to production, and be able to distribute internally and externally faster using this technology. This gives you scalability, so you can manage spikes of concurrent downloads and distribution. So it helps you achieve that scale as we get to hundreds of billions of devices. Your network will actually be able to handle all of that large load in a peer-to-peer fashion. You're improving the performance and the network utilization and the resiliency of your system. So this improves the uptime of your overall system. And this is a proven technology which we've been building and using with our enterprise customers for quite a while now. So I hope this was informative, learning a little bit about the ecosystem for edge devices, some of the challenges with pushing to large Kubernetes clusters or to devices where you have to push things to a large portion of edge nodes, and how you can apply peer-to-peer technologies to this problem set to improve the performance and ability of your network to be able to handle the load. So feel free to ask any questions you have about kind of these use cases, about the technologies, and also something else which I'm working on is a new book about DevOps tools for developers. So if you have any questions in general about source code, CI/CD, about kind of how you can build microservice architectures or how you can deploy, I'm also happy to talk about and answer questions along those lines. So thank you very much for having me as a speaker at this event.
Thank you, Steve. Thank you for the great slides. I really loved it. And it's interesting to see, especially how JFrog can be useful for the edge devices, right? So definitely that is one area which I am working, and most probably I can connect you back to talk more on that. Thank you so much. And I was just looking at the questions. I don't see anything else. So we are good.
Okay, thanks so much, and I hope everyone's enjoying the event. It's really awesome that you're able to put this on virtually. I remember attending a bunch of like all day Saturday seminars when I've been in India before, and it's like it's even better in person to have like the collaboration and like people sharing use cases from the community and their technology expertise. But I'm glad you've been able to take this virtual and also make it possible to do this.
Yeah, thank you. Okay, so we move now to our next speaker, who is right here, Aditya. Aditya, can you hear us?
Yeah, I can hear you. Okay, can you hear me?
Yeah, I can hear you. Meanwhile, I will go ahead and introduce you, but it would be great if you can go ahead and share your screen so that
Yeah,
I can.
let me share it.
Yep.
Yeah.
Okay, so a little intro about Aditya. So Aditya is currently working as ATSC OpenShift engineer at Red Hat. And he's also AWS community builder and leader at CNCF, community leader, a Lyft cloud captain, and an open source guy. So he's here today to share with us GitOps and the next big thing for DevOps and automation. So over to you, Aditya. So let me go ahead and stream your slides. Or there you go,
Yeah.
Aditya. Go ahead. Yep.
Yeah, thanks a lot. Yeah, thanks a lot, Ajit sir, for introducing me, and welcome you all at Docker Bangalore JFrog Community, and I can say Collabnix Joint Meetup 2021. And this will be a great platform to, I think, learn a lot of things. Okay, because there is lots of, I can say, different kind of session you can get at a single platform. Okay, so let me start with the topic. So I am here with the topic like GitOps, the next big thing for DevOps and automation. Okay, so you must be heard about like DevOps. We are moving to DevSecOps, but yeah, there's GitOps, another term that is already we are moving towards, like big companies, or I can say big industries, experts are just moving towards this methodology to use this in their running environment, or I can say just integrate with the ongoing life cycles. Okay, so how it goes and what are the things are there, we will be just discussing in today's event. Okay, so let me just introduce myself, because if you are listening me, then you should know who is this particular guy. And as Ajit sir also like mentioned, but let me give it again a try. So as you know, like I'm at the Sony. I'm working at now as ATLC at Red Hat, and I'm also a AWS community builder. Recently, I have started my two own I can say communities, CNCF Jaipur and AWS Community Jaipur, and yeah, there are lots of things. I think you can catch up me on LinkedIn, or like, if there's any query or you want any of the doubts to be clear, then just ping me on LinkedIn or the mail ID. Okay. So what will be the agenda of today's talk? Okay, so the agenda, I will be covering the three most terms, like what, why, and how. So what is the GitOps? Okay, why you should learn it, or why you should actually listen about it. Okay, or if you are already using DevOps or something, then why there is a need to actually integrate these kind of tools or this kind of methodology to your running environment. Okay, so this will be discussing, and how you can do that. Okay, so at the last of this particular short session, I will be just giving some brief about like what are the tools are there and how you can integrate with your clusters. Okay, Kubernetes clusters. Okay, so this will be goes like that, and let me start with the brief. Okay, so the brief will be about like, so we will be checking brief about today's topic, like where we was and where we are moving to now. Okay, so the thing is, we are just in the evolution of approaches. Okay, so if I say in IT, so previously you are using the waterfall model or the agile methodology to ship and build our what are the pipelines we have, what are the softwares we have. Okay, but now after that we just move to the, I can say, DevOps. Okay, previously we are doing everything by manual processes, but then we move to the automation. We are writing the scripts. Okay, so previously what we are doing, we are just creating a single task, and we are just performing them. But now we are going to scripts, and we just run one particular script, and all the tasks are done. Okay, previously we are creating our what I can say, the packages. Okay, the bash packages, or I can say some package we write, and some bash script also we write. Okay, but by them we are just automating our things. But now what we do, we actually containerize everything and ship that container to the other people or other teams. Okay, so the next thing are like to maintain our whole infrastructure, we was creating the spreadsheets. Okay, so but now what we are doing, we are just creating everything by the configuration as a code. Okay, so what we have to do, you have to just write whatever the infra you have as a code, and that will be automated by Terraform or any other kind of tools. Okay, market. Okay, so the next thing about the how DevOps comes. So there are lots of teams like there was a development team, there was an operation team, there was a security QA. So we have just created a whole pipeline, and we have integrated them whole in a particular cycle, and then we just termed it as a DevOps. Okay, the next thing is like previously we are focusing on the CI, like to integrate each and every tool. Okay, but now we are in like focusing on more on the CD part. Like we have integrated everything, but how we will just ship it to the end user. Okay, so that particular CD, or I can say the continuous delivery part, we are focusing on. Okay, so that's where actually these GitOps kind of terminologies or whatever I will show you today, that will be live. Okay, so the evolution of ops and CD approaches previously was on DevOps, but now they are just moving towards the GitOps. Okay, so that's how actually it's going. Okay, the next thing is so what is GitOps? Okay, so what is GitOps? Or if I say GitOps is a term, and as you can check like GitOps, so it's already concluded two terms like Git and Ops. So by the Git, you can just manage your source code, and Ops, the operational teams will be doing the thing, but it's not the summarize of it. Okay, so as you can check in this particular diagram, there are the two teams. There's a development team and there's a production. Okay, but now what you can do, previously what we were doing, let me show you. Okay, let me explain you. Okay, so there was development team, they was pushing their code to GitHub, and that code just maintained by any of the pipelines or something, and then they go to the production environment. But now what we are doing, we can just do our code or whatever things are there, we can just do it, just push the Git, and by the Git we can just maintain our production environment too. Okay, so the mean is like whatever the manifest are you creating for the Kubernetes cluster, you have to put in your Git repository, and that by that it will be synced by your production environment. Okay, so that's how it will goes. So like Git in GitOps, what we use as a Git as a single source of truth. Okay, so whatever written in your Git, that will be your single source of truth, or that will be monitored by your operators. Okay, so in GitOps we just rely on the operators, or they are the robots, they do all the work for you. Okay, so like robot do all the work. The mean is like the operators are there, and that they will be doing all the work for you. Okay, so in this we can write a declarative configurations. Okay, so what are the configurations you have for your on running environment? You can just write in your declarative configurations, and that you can push to your Git, and that particular Git will be synced with your any of the GitOps tool. Okay, so that's how actually it goes. Okay, and the next thing is like you must be having question like we are already on the GitOps, we are already integrated our whole pipeline with Jenkins or any other tool available in market, but now we want to move towards this particular thing, I can say GitOps. So what were the challenges, how we will do that? Okay, so things like that. So later I will show that. Okay, so the thing is, as you can check, this is the traditional approach. So in traditional approach, what actually developer was doing is he was just pushing it code by the kubectl, or like he have manifests. Okay, he have manifest ready, he have all the, I can say, images that are pulled already on the registries. He are just updating that image by any of the pipeline, CI pipeline, and then it's just pushing that image to by the kubectl or the direct approaches. But now what you can do, that particular developer don't have to write the manually kubectl or any of the commands he was running, or any of the manual process he was doing. What he had to do, he can just create another Git repo. Okay, so in the one repo your code will be there, in another repo your manifest or the configurations will be there. Okay, so your whole manifest will be in the configuration repository, and as you can check like at the state continuously monitor diagram, so in this there is a, I can say, the green sync symbol, so that is the operator. Okay, so that will be checking your every time your any changes come to the Git repo, so it will be checking that, and accordingly it will be update your clusters. Okay, so that's how it will goes. Okay, so yeah, so it was like how it works. So at backend, because I said you like these things are working, but at backend how the operators are working, how these things are actually integrated with the GitOps, or I can say with the Git, how actually they are working. So in Git there is a desired state. Okay, so the GitOps actually what it does, it just create one desired state for your Git repo. Okay, so this is the desired state, or this is the state that particular developer or particular guy has created. So he have to maintain that particular state, desired state. Okay, so GitOps operator, it will always maintain, or it will always check your desired state to the actual state. Okay, so actual state is, let's say it's behind, as our, I can say, any of the push you just didn't able to do on your Git, so it will say like you are behind from that particular branch. Okay, so that's how it will monitor, and it will check like it's already not on actual state, so it will just sync with it, and there are like observability tools, and that will that will do their work. Okay, so what other tools are available in GitHub? So the first I can say like Argo CD. Okay, so Argo CD is like declarative continuous delivery tools for the Kubernetes. Okay, so any of the clusters you have, so you can just declare your whatever the infra you have, what are the things you have, just declare that, and that will be it will be do for you. Okay, and there are lots of tools like alternatives, there's the Flux CD, there's Jenkins X. Okay, so there's a Verve. Okay, so there are lots of tools that you can check on, just I can say just type on GitHub like GitOps, and you can get all the tools. So today's talk, I will just go through with the Argo CD. So like the main thing is like why we should use these tools or something like that. So the thing is, now industry are moving towards the SRE. Okay, so the like site reliability engineering rules. So why they are getting so much famous? Okay, so let me just go back and just show you again this slide. See, there's a development side, there's a production side, but you will think like where will the DevOps role will lie in? Okay, so now lots of things, or I can say the SRE team actual, they can maintain your code also, and they can maintain your, I can say, the operation, the infrastructure things also, the production environment also. Okay, so how they can do that? So that's why the GitOps thing actually play role, the major role play there. Okay, so the only guy who are just building their code to that particular, I can say, production, who will be just maintaining your all the approaches. Okay, so let's just move to the Argo CD. So what's this? So it's a declarative, I can say, GitOps continuous delivery tool. Okay, for Kubernetes clusters. Okay, so whatever I can say templates you have Helm charts, you have Kubernetes, you have any of the like the declarative thing you have, you can just put it on that particular repo, and it will just sync with that by the help of operators. Okay, so yeah, it works on the configuration. So they are the features of it. Like it's have the multi-cluster environment. You can use just multi-cluster in your different environment, and you can just integrate them. Okay, it's have some configurations, extensibility, rich CLI or rich GUI, you can say. Let's say if you are a CLI guy, then you want to use that particular configurations not by GUI. You want to do everything by that particular CLI. So you can do that. There are all the functionalities are available there. Okay, so how actually Argo CD works? As I said previously also, like you have your ongoing environments. Okay, because you are already on DevOps, you have already created your whole pipelines are there. But now where the GitOps play through, okay, the thing is like you can check there are the two Git repos and there's one developer. Okay, so if I will check you, so this particular repo is for your application code. Whatever applications you have Java applications, you have any kind of application, Flask, or I can say any of the applications that you are running, that application code will be here. And the ongoing CI pipeline will be, you can just mark it as it is. Okay, so the CI pipeline will be there, and after that CI pipeline, what they do, they will just build your code and they will just push your code to any of the Git repo, I can say any of the image registries by the new tags. Okay, so that tags will be there. But now where the GitOps play its role is like whenever this push will be there on the image repo, that that particular tag will be updated to your this particular repo, and this particular repo is for your all the manifest. Okay, so what are the things you want to do in productions? So you have written your manifest file, you have written for any of the things that you want to apply or in Kubernetes cluster. So just keep your files in this particular repo. Okay, and that particular tag, the image tag, will be always actually updated by that particular, I can say, the CI pipeline itself. Okay, and that particular repo will be monitored by your Argo CD. Okay, so Argo CD actually monitor and Argo CD sync. There are two types of syncs you can check, the manual and automatic. Let's say if you want to, if you are using the continuous delivery approach, then you can just use that. And if you're using continuous deployment approach, then you can go with the manual, or I can say the manual, or I can say the automation sync. Okay, so that approaches are available there. You can just check it out, and I will show you also. Okay, so later on you can just create, or I can say attach your all the clusters are available there. Like let's say you have different environments, you have dev, you have test, you have prod. So you can just create environments, and you can just like tell Argo CD or just write the declarative configurations like this is the particular cluster where the code first should goes. And let's say if there everything is working fine, then you can just patch it to the another, I can say, clusters. Okay, so that's how it will go. So this is the simple architecture of Argo CD. So actually how it's work, or at the backend how it's actually connected. Okay, so you have end users. So end user will be connecting with the Argo CD by that particular, I can say, Argo CD server. Okay, so Argo CD server is the first thing where you hit. Okay, so as in Kubernetes we just hit to the API server, that's how actually in Argo CD we just hit to the Argo CD server. So any of the commands or any of the instruction you are giving by the CLI or the GUI, that will be first goes to your Argo CD server. The next thing is about the GitHub repo. Okay, so GitHub repo will be maintained by your repo server. So you have different kind of GitHub repo. You have not only GitHub repo, any kind of SVC you can connect with it, and I can say the repo server will do its work. The next thing is about the app controller. So app controller will be maintaining your all the clustered environments. Okay, so whatever applications you have, whatever clusters you have, so it will be maintaining that particular things. The next is Redis or Dex server. So in this particular Redis or Dex server, it will maintain your all the metadata. Okay, so whatever the store, like I can say, what are the builds you have done, what are the commits you have done. So you want to maintain a particular, I can say, history of it. So it will be take it for you. Okay, and you can connect with the multiple clusters that are there. And yeah, so as I said previously also, like Argo CD, you can set up with the GUI or CLI. So yeah, you can definitely do that. If you are doing any CLI setup, then you have to write this particular, I can say, the configuration file or the manifest file, as I have written at the, I can say, left side. And on the right side, you can just create your, by the GUI, you can create a new application also. And I will show you both. Okay, yeah, so let's jump to a quick demo over this, and then we can just conclude it. Okay, so what I have done, so I have this my Kubernetes cluster already running in Google Cloud. Okay, so let me just reconnect it, and yeah, so that is connected. And what I have done, the next thing is like I have created my some manifest file that I have put it in my GitHub repo. Okay, so this is my GitHub repo, and I have created some small YAMLs there. Okay, so these are for MySQL deployment, and these are for there are, I can say, rollouts like Canary or Blue Green. So I have created the, what I can say, the manifest for them also. Okay, so what I gonna do now, so this is the actually the repo I have, and I will connect this repo to my GitOps server. Okay, so that I will connect, and what I will do, I will just change the image tag every time. Okay, so let's say the developer, the CI pipeline, what it will do for you, it will just change your image tag every time the new code is there in the application side, and that will be routed to your, I can say, this particular Git repo where all the manifests are there. And this manifest, whenever I will just update them, it will be just routed to your Kubernetes clusters. Okay, so how it will goes, let me show you quickly. Okay, so this is the particular, I can say, UI. After installing the Argo CD, you will get this particular UI. And this is, I think, I can say, like, this is the basic, or I can say, to install it, it's not a big deal. You can just Google it, and just the 4 or 5 simple steps, you can just install it in your any of clusters. Okay, so this the particular application I have just created previously, but I will not using this now, so I will just create a new one for showing a demo quickly. So I'm just putting name as a joint meter. Okay, so yeah, so you have to give application name whenever you're creating any applications. Okay, you can create any of the projects. Okay, so projects, like I'm just using my default project. And the sync policy, as I said, like there are operators, and they do their work by the sync. And now you can choose, you want to use the manual sync or automatic sync. It's mean like whenever the code is changed, or I can say the code is pushed to your Git repo, this should be automated approach to deploy a Kubernetes cluster, or this should be manual. So you can just choose it here. Okay, so now I am using the manual approaches. Okay, and the next thing is, like, these are the options. Sync options are there, like like you have some different environments, then you can use them. And it's asking me for the repository URL, so I'm just putting my, I can say, the repo URL to this, and this is my repo. I have created all, I can say, GitHub. So yeah, head version it, like revision is head, and path I am just giving because I have created one folder there. So you can create some different folders, and in folder you can put your code. Okay, so in Argo CD I have created some manifests there. Okay, so that's out then, and it's asking the destinations. So in destination you can give your Kubernetes cluster. It can be this cluster can be your where you install Argo CD. It can be a different cluster. Okay, it depends. So let's say if you want to do in a different cluster, then you have to just write that particular configurations to the, I can say, you have to add that particular cluster to that particular, I can say, configuration. So now I have added my default cluster, so I'm using this, and for this particular thing I'm using the Argo CD. Okay, so I'm pushing all the code in the Argo CD namespace itself. And yeah, that's how actually the directory recurs, and it will goes, and you have to just create it. Okay, but now I'm not creating it because it's already there. And let's say if we want to do, then like we can do it quickly. And so this is the thing, like we have already created. So it's showing me 8 warnings. So what I will do, I will just sync it. Okay, so as I said, we have to do manual sync there. Okay, so I am doing the manual sync, and after the sync is okay, or it will show you like it's okay or not. Okay, so it's actually sync is okay. It's mean it have already deployed whatever the YAMLs are there in your Git repository. So as you can check in this particular thing, like all the YAMLs was there, it has just deployed them. Okay, and you can just check it out. Okay, so yeah, so actually this is the particular, I can say, whatever the infra you have just defined in your, I can say, because as I said, it's already a declarative configuration approach. So whatever infra you have just declared, it's already, you can check everything. You can check what are the endpoints are there, what are the I can say the pods are there they have created, what are the services they have created. So you can check everything. So as I can check, like I have 6 pods created, I have some replica sets created, I have some these kind of things created. So let's say if anything is just updated, so it will update only that particular kind of that particular thing. It will not update your whole, I can say, the whole application. It will not do that. Okay, so it's done. So let me show you quickly, like so it's done, and we can check in our cluster, just running this particular command. So you can check like our this whatever the applications we have deployed, it's already deployed in your cluster environment. Okay, so let us do quickly. Okay, so in meantime, yeah, so yeah, you can check like there are the services already deployed, like the blue, green, or I can say these all services are there. And so what I have done previously is like, so there was one service, or this is the code I have created. Okay, so one service I have routed as the load balancer, and that you can check here. Okay, so this is the service already in my Kubernetes cluster. You can check it here. And this is the service I have exposed as a load balancer. So you can check the code here. And it's taking the green balls only from this particular repo, because what I have done, I have just written here for the demo, like I am using the green. Okay, so the green container, it's taking up. Okay, but let's say your save pipeline run one time and it's changed this particular code from green to any of the color you want. Like I want to use the red. Okay, so red, or it will be image tag. It depends on your particular commits, because it's a basic example. So I am just showing you this. So let's say I have created this red, but now what it will do? So now we again can go to our this particular thing, and in applications I can what I will do, let's say, because I have created the code there and it's saying out of sync because it's not synced with your whatever changes you have done in your desired and actual states. So you have to do the manual sync because we have choose that already. And yeah, so it will be sync, and when it will say like sync okay, so then our this particular code will be, let me just refresh it. Okay, so now here the red balls also will start to up because I have used the blue green approaches. So what how it will goes, it's just started to pushing all the red balls started. Okay, and let's say another developer just pushes the another tag. Okay, so let's say again I am doing what I'm doing, I will just again change the image tag. Okay, so now how it will goes, let me show you quickly. So let's say I have just created another tag to my image and I am just committing the changes. Okay, I have just committed my changes, and you can check like there are red balls are there are green balls are there. Okay, because previously the environment was on this particular stage. Okay, but now it's coming to the red. But why it's not coming to the blue now? Okay, because we have already chosen the particular manual sync, not automated sync. Okay, so what I have to do, I have to just go again here. So let's say if you are using the continuous delivery approach, then what you can do is don't stick on the manual things. You can just use your sync as sync as what I can say. Yeah, sync as an automatic thing. And let's say if you don't want to use the automatic, then you can just use the manual approaches. So now I have used the manual approach. So see, so there are no containers, or I can say no balls was for the green. Okay, but now when I will refresh this particular thing, because I have already synced, so every ball will be blue only, because I have removed my all the previous containers or the previous application replicas from that particular code. Okay, so that's how actually it will go. So what you can do, you can maintain every of your what are the configurations are written there, you can just maintain whole around it, and you can just use. Okay, so you have to create two repos, as I already said. One is your application repo, second is your manifest repo. So application repo is on the their place and the manifest repo on the their place. Okay, and the manifest repo or the application repo you can build in or integrate with your CI pipelines, and this particular repo you can just integrate with your I can say CD tools, any of the CD tools, and they will do their work. That's how actually it's working now also. Okay, so yeah, I think that's all about this demo, and to use this particular I can say Argo CD or the GitOps approaches. So this is a particular one tool you can use. Many of tools are there, as I said in my PPT also. So yeah, you can just go through by it and just use any of the tools are there, available there. As we check, like there are plenty of tools are there. So I have just shown you the Argo CD, but every tool has their own I can say what I can say the use case. If you are using Jenkins previously, you can move to Jenkins X. Okay, that will give to you the another approaches, or I can say another features. Okay, so yeah, that's all about this particular demo. And yeah, thanks for just listening me, watching me. And if you have any questions, you can just put it now, or let's say later on, you can just ping me on LinkedIn or anywhere. Yeah, thanks a lot.
Thank you so much, Aditya. This is a really, really great talk, and you shared a lot of really, really great information. A lot of traffic near you tonight, huh? But
Yeah.
but really, really appreciate it. I don't see any questions in the chat right now, but that can change. So, will you be joining the YouTube channel just in case there's some additional questions regarding your talk?
Yeah, sure. I will be there. I will be
Awesome.
there at backend. Yeah.
Awesome. And again, I'm sorry the courier did not get your JFrog shirt in the mail fast enough. I followed up on it today.
Yeah.
You will get it, I promise. But again, thank you so much. We do have a question actually. It's from Madhu. Can you see it?
Yeah, I can say it. Does Argo CD monitor the resources which are not in Git but created on cluster directly? Yeah, it can monitor. But the main use case of Argo CD is like to monitor your, I can say, declarative configurations in your repos. If you are doing that manually by the cluster, then I think there is no use to use the Argo CD itself. Okay. So yeah, it can use, if you are using at the backend, you can just sync it, or it will be do according to your approaches. Let's say you are used as a, I can say, automatic sync, then it will be sync automatically. Or let's say if you're using manual, then you have to just go on that particular GUI and you have to push that particular sync after doing that, okay, by the backend. Okay, so that can work. That's not a big issue. Madhu, I think that's answer your question.
Great. Awesome.
Yeah.
Well, thank you so much again, Aditya. I
Yeah.
really appreciate it.
Yeah, thanks
And,
a lot for inviting me here.
Pleasure. Well, we are going to introduce our last speaker of the evening. And Arun Kumar is a solution engineer at JFrog and holds multiple technical certifications in the programming and cloud native space. Arun has been in the industry for more than 12 years and has extensive experience as both a data scientist and a software engineer, really in multiple industries, including banking, e-commerce, and also in the cybersecurity domain. And loves encouraging diversity in technology and is passionate about contributing back to the community, which is why he's with us today. Arun, thank you so much for coming today, and you'll be sharing with us today on DevOps for machine learning, which is an exciting topic. So without any further ado, I want to welcome Arun.
Hey, thank you, Ari, and thank you again, the Docker community, for having me. I hope you can see my screen, right? Ari, can you see my screen?
I can see your screen. I can also see the slides on the side. I'm not sure if you're in presentation mode or not.
Okay, I'm moving into the presentation mode. Is it fine now?
There you go. Yeah, perfect.
Awesome. That was a great talk, Aditya, and I really like the tool. Probably I will add it to my list of things to learn probably this year. And thanks for having me again, guys. It's been a wonderful feeling. I had a great day today. It's a wonderful start of the week, probably end of the week, probably you can say that. Let's get to business. Today's topic, it's DevOps for machine learning. So I want to touch upon this particular topic because it gained a lot of momentum in the industry, and that's predominantly what I would like to showcase, and how you can use the existing tools and other things to leverage this. Again, a quick disclaimer, this talk is based on my complete personal experience, okay? And no offense to Marvel fans. Who am I? As Hari said, I'm Arun. I'm working with JFrog as a solution engineer. I was also part of a data science team in my past. I've been part of multiple domains, and I really like, I'm really passionate about data. So that's where it brought me to JFrog, and I'm really interested to be part of this speech as well. So this is the agenda. We are going to start with a basic introduction. We want to understand first what is ML, what is MLOps, and all these things. Then we will move on to a little bit that we are already familiar with, a DevOps overview. Slowly then I will transition you from the DevOps mindset to MLOps mindset. So that is the agenda for today. Then I will show you the existing tools that are available in the market. Then we will see a quick demo. I prepared a small demo so you can see the end-to-end flow of DevOps using an existing DevOps tool itself, end-to-end MLOps, sorry for that. So probably I might not be able to respond to your queries right away. After the session, I'm happy to do that. So, but before diving on to this topic, right, let us understand why MLOps is predominantly important, why we need a separate ops first of all, right? So, though a lot of companies are being adapted towards machine learning, right? And though a lot of new things are happening in the field of data science and other things, still, as of last year, this is from the famous people like Gartner and Deborah Leff. She's a former CTO in IBM. They said more than 85% of machine learning models just stay in the research phase. So that is not something a return of investment, right? You do always research, and if you're not getting anything out of it, right? So that doesn't make sense. So that's what started my investigation. That's where I started my investigation. I wanted to understand why it was like that. What are the different challenges that people actually face in productionizing their model? So that's how I started my journey as well. Okay. So before you ask me the question, I know this is the question exactly I asked. Is it something worth investing my time? So that is exactly the same question. So this is again a famous report. They said this year would be the best year for MLOps. Okay, and I'm just putting the numbers conservatively. They just put something around 60 billion in the next 6 years, but the trend is actually increasing a lot. Lot of new tools, new practices are being formalized for handling the machine learning in production. So the trend is real, guys. So it's better to start invest time in learning these things. Okay, so let me take a step back. I wanted to understand whether this pattern occurred in the industry before. So when I thought back, right, this was how the DevOps actually was there. The development process was there before 2010, right? 2010, before a lot of chaos in the development, there is no streamlined process and of all these things until we get DevOps as a methodology to streamline the whole things, which led to the advent of large software systems, of microservices that we see today, right? ML development is in a similar space now. So it is like as we saw before a decade, and MLOps probably will be a good solution to streamline the whole process. And we also have a good experience with DevOps, so we can leverage these things, okay, which will lead to the mature ML services. So this is from the pattern matching. That's what data scientists will do. So probably you might ask a next question to me. Okay, this seems interesting. How is MLOps different from DevOps? To give you an answer, right, let me probably give a statement that I found over the internet. MLOps is different from DevOps in the same areas where machine learning is different from traditional software development. So let's take a bottom-up approach, right? Let's understand how traditional software development is different from machine learning. Then we will take us further how DevOps is different from MLOps, how we can leverage these things. I believe you also had the similar question on mind. Okay, so very simple slide. On the left hand side is what you find at traditional programming. On the right hand side, a machine learning thing. Okay, so what does a traditional programming does, right? You have a data and you need an output. For that, as a developer, you will write a code, right? The code is the bread and butter of your software development lifecycle. I presume you agree with that. I'm sorry, I'm not able to see you guys, but I presume you agree with that. So the only thing that matters in traditional software development, right, that is the code. So that is why we have a version control and all these things that revolves around the code. Straight away to the machine learning. So in this case, right, we are not writing the logic, the algorithm. Okay, we are giving the data. That is this is the input, and if this is the input, this will be my output. Okay, the supervised learning per se. Okay, we are giving that to a machine learning bot, and we are asking the bot to come up with the algorithm. This algorithm the human wrote. In this ways, we are asking the machine to come up with their own algorithm. So in this case, right, think logically, right? What are the different changes that can happen? The data, if data changes, the model will definitely change. When I say model, what do I mean is the algorithm will definitely change. So I need a mechanism to not only track the code, okay, which we saw in traditional programming. We also need efficient mechanism to track data as well as the model or the rule. Okay, this I hope you understand the basic difference between a traditional as well as machine learning model. Okay, now you understand the basic difference, right? A follow-up question that I had in mind. Okay, I can do this, I can track all these things, but does it really require? Do I need to deploy or change the data or the model continuously? Will the data changes frequently, or will the model need to be updated frequently, right? That is something, a very valid question. Machine learning probably is the only industry I'm aware. When you deploy a software, the performance of the software will degrade. Okay, so what do I mean by that? I have a good example which I took it from a Reddit. So this is something I found funny. Facebook's list of suggested friends is quite literally a list of people I've been avoiding my entire life, not me. I just took it from a Reddit. But this is what happens when you have an outdated data and an outdated model. So you need a better mechanism to update the model frequently in an efficient manner, and also to keep track of the changes that happens in the model. Okay, so this is a requirement that we need to also consider. So now we understood everything. Now we understood the basic difference between machine learning, traditional software development, everything. Now, how does the DevOps would be different from machine learning, right? MLOps. So this is a famous slide. I presume most of you folks are from the DevOps background or somewhat affiliated to the DevOps side. Okay, this is a famous infinity that you know. It's a union of people, process, and products to enable the continuous delivery, right? And to give you a much better perspective, right? These are all the practices that been predominantly followed in the industry. As a company, JFrog, right, we provide end-to-end DevOps solution, okay, which covers predominantly everything here and much more. But these are all the major things or practices that you need to consider while following the DevOps or implementing the DevOps, right? Version control, continuous integration, CD, monitoring, all these things. Okay. Now, let us understand the MLOps from this perspective itself, right? Before that, I need to tell 2 more points. This is something I already discussed. The changes that you need to consider when, in addition to the DevOps lifecycle, that is something that you can see in the screen. I have an ML, that is the data and model added to the DevOps infinity, right? As you can clearly see. The definition, you cannot find much better definition than in Wikipedia, so I just pasted it. And MLOps, right, is a term that is coined by Google. Okay, it's something very new. Google coined this term somewhere around 2018-19. I'm really not sure about the timeline. It's very fairly recent, and the market is not that mature. Okay, so that's why people are struggling very hard to get these things rolling. So now you understand the definition, right? What might be the challenges? Okay, now I understood. I have a ML code and I need to consider data as well as model during the code, right? But does that take care of everything else? To answer that, Google has an answer for that as well. This is taken from this paper, Hidden Technical Debt, a wonderful paper. I'll given you the source, please have a look at it. So whatever I discussed, right, the machine learning code that a developer or data scientist, all these guys write, right? That just comprises of this black box. In real world, these are all the different things that ops guy or a machine learning engineer need to tackle, okay, to get your model productionized. So this gets serious, okay? It's not just your laptop, your notebook. It doesn't stop there, okay? It gets much more serious, okay? So what are the best practices? I want to use the yes, please. Okay. Okay, so now we know the DevOps best practices, right? Can you map it with the MLOps practices? Of course. So in terms of version control, I already told you, right? We need to track code, we need to track data, we need to track model. So there are multiple tools, okay? Code, we use a standard GitHub. For data, you can use something called DVC, data version control, or there are other tools, open source tools like Feast, which is a feature vector. Okay, even you can use a JFrog Artifactory. That also solves the problem. Okay, and for model, again, you need a model registry. So Artifactory would be a perfect fit for it. I will show you what do I mean by that. You need an efficient way to track all these things. Why do I need to track all these things? So when a data scientist writes a code and executes certain things, right? So what happens? He runs an experiment and he gets a prediction result. Okay, if I automate it, if somebody else, QA guy, takes the same data, same code and all these things, try to reproduce it, he should also get the same things, same results. So the reproducibility is a major challenge when it comes to MLOps. I need to reproduce with the same data and same configuration. So there is a need to maintain all these things. Okay, and during CI phase, right, I also need a way to continuously train. We saw why continuous training is important with the Facebook slide, right? And when it comes to delivery, apart from your application delivery, you also need to consider model deployment, because that is where your predictions come out of, right? And the another major aspect is monitoring. What do I mean by that? In terms of machine learning, right, when I deploy a model, we already discussed it might definitely degrade in the future, right? There are multiple concepts like data drift, model drift, etc. I'm not going to touch it. but you can leverage the existing tools like Prometheus, Grafana, even JFrog's, all these things you can still use to monitor your model. So this is the relationship between DevOps and MLOps, and this is the basic difference between these two. I hope you understood all these things. You might ask a follow-up question. Okay, this seems interesting, and I would like to know more about it, right? But where to start? Do I need to start from scratch? Just like probably if you guys more than 12, 13 years, right? Just like how you started back then, like DevOps, right? And do I need to start from scratch? So to answer that, we have an amazing framework defined by Google. Again, I would like to touch upon Google. There are other models as well, but I like this, and they came much early in the spectrum. 2019, I think they released this. What they call it as maturity model. Okay, when you are planning to automate your ML lifecycle, right? These are all the methodologies that you can consider while doing it. They defined it in 3 different layers. One is what we call level 0. That is no ops, no operations at all. You can completely manual. Level 1, you are probably automating the CD aspect of it. Okay, just the pipeline automation of the CD side. Level 2 probably is where we try to achieve, where it is an ideal thing that we want to have, supports a full CI/CD pipeline for all ML activities. Okay, starting from data gathering, testing, multiple testings are there. Okay, infrastructure testing, ML model testing, different things are there. Regression testing, for example, if you go with regression model. So a lot of things you need to consider, but automating the end-to-end spectrum, this is an ideal case, and it's not simple to achieve, but we will be there definitely in the near future. I don't want to deviate the topic. That's why I haven't added the picture of the levels defined by Google, but I will add the source here probably before I share the slide. You can have the look at it. Okay, that's pretty straightforward, and they have a detailed explanation of what each level need to be accomplished. So now you understood what is the basic difference, what are all the things I need to do. Everything is already there. Now you have something to start with, right? Probably you say, I'm confident, right? Nothing bad can happen. Just like how Ned Stark said, don't be like a Ned Stark. I hope some of you guys are at least Game of Thrones fan. So you know what happens to Ned Stark after this. You need a Jon Snow or somebody else to keep his legacy up, but keep that aside. So predominantly, right, Google discussed everything. I really love what they discussed. But one particular aspect that I felt that's not given much importance is security. I've also listened to one of a good DevSecOps session from a Cognizant person. So it was really enlightening. And as a company, JFrog, we also have too much focus on DevSecOps. We have a dedicated tool to do these things. So my thought process, right? Probably I'll show you the next slide. That would be funny. So security is something that you need to consider much early in the process. I've been part of a cybersecurity domain for quite some time. Okay, we've seen a lot of challenges in the cybersecurity domain. When it comes to machine learning, right, there are still a lot of challenges. Like you can come across like model evasioning, poisoning, stealing. A lot of things can go wrong. Inferencing. Okay, you need to consider all these things much early in the process. Just like how we do in JFrog, how we promote it like shift left. It's 11 times cheaper and effective to fix something at the source like IDE, okay, than you fix something at the production level. So it's always better. So suppose you did everything, MLOps is phenomenally working, and you deployed the model without security, and you're getting this slide. You're implementing a model for a medical field, and this is what you get. Okay, it says you're pregnant, it says you're overweight. There might be a lot of reasons. Okay, there might be model might be biased, data probably not distributed, overfitting. A lot of ML related issues can come in, but let's keep that aside. Assume all the ML things are taken care of. I haven't considered security here. So somebody, I hope you are aware of the recent SolarWind attack, right? That was a massive breach that happened in US, right? It's because of a very simple change in the jar file, open source dependencies. Okay, so that is something that need to be focused, because we had a great experience in DevSecOps. We've seen what can go wrong in industry. Okay, so it's better to think we don't have a time stone just like Dr. Strange, right? We cannot turn back everything. It's much better to practice everything much earlier in the process. So I will show you what do I mean by that in the demo. But you might ask me, right? Okay, everything seems interesting, right? A lot of big companies like Facebook and other guys are also using machine learning. How are they using it? They have built their own platform. Google has a TFX, but the public version is not that mature. My 2 cents, my opinion. Uber built their own service called Michelangelo. FB Learner, Facebook has their own thing called FB Learner's Flow. Airbnb has their big head. If you ask me, Netflix, I think they are using Metaflow. I hope you're aware of a company called Lyft. They are using something called Light, which they recently open sourced. Big brother of Google, the Microsoft, right? They built their own platform called Aether. So big companies, right? They have hundreds of ML engineers too. So they don't need to rely on the manual process. So they built their own platform. But companies like small scale or medium scale, right? We do not have like thousands or hundreds of machine learning engineers dedicatedly working on these things. Where do I start? You might ask me that question, right? So to do that, you need to build your own. It seems overwhelming. Don't get overwhelming, okay? It took me off a bit as well. But you need to do a lot of things. So this is not the only solution. You can pick each and everything and build your own tool. Or my solution, right? You're already familiar with the DevOps tools and all these things, right? Why not leverage the existing platform and come up with a solution which might fit your case? Anyhow, you're building one, okay? There are some end-to-end platforms as well. Like Azure has a brilliant platform, which I personally like. They have the end-to-end MLOps lifecycle. And one of the paid subscription that I'm aware of is Valahai. Okay, I haven't personally used it, but I'm aware of it. So there are a lot of companies who try to bring in their end-to-end lifecycle because it's still not in mainstream, because the challenges are still being discovered and being solved in the industry. I believe in a couple of years will be there somehow, but then a miracle occurs. It's not a sales pitch, okay? What do I mean by miracle? I already gave you an answer, okay? You already have a DevOps platform. You are already aware of something that you've been experiencing for the past decade, right? Why not leverage it? Why not leverage it, right? So that's where in this demo, I'm not going to use, probably I'm going to use our own product, JFrog platform, to showcase an end-to-end DevOps lifecycle. I will show you the high-level architecture. Then I will show you how I did it. I might not be able to run it because that particular demo will take more than 10-20 minutes. But I will show you the things that I have ran and the steps I did. Okay. So this is the platform I'm talking about. I'm predominantly going to be using the JFrog Artifactory for storing my models as well as the data. I'm also storing the data here for full reproducibility. And I'm going to use X-Ray, that is our security solution, to keep track of all the vulnerabilities or open license compliance, anything that comes into model before I make the deployment. Okay, and I can use our JFrog solution pipeline to automate the complete stuff. Just like Aditya said, Argo CD, right? You have multiple tools, but personally, I like pipelines. But for this demo, I used a different tool. But all these things that I mentioned in the platform, most of it are available in our free tier. So probably you can create a free tier instance in JFrog SaaS solution and you can try it out. Okay, I will share my code, publish my code. You can try the end-to-end lifecycle if you are interested. But Artifactory and X-Ray is what I'm going to focus more today. If you are interested about other things, please ping us. Okay, we are there to help you out. So this is on a high level what I'm going to showcase in the demo. Okay, so I intentionally abstracted a lot of low-level information. What do I mean by that? When you take the data science training, right, there are a lot of different things involved. Feature extraction, feature engineering, exploratory data analysis, model building. And during this process, I also need to take care of a lot of tests related to machine learning infrastructure, model testing. A lot of these things are there. I intentionally abstracted it because it will extend beyond NAR. But I've used a lot of tools in Python. Predominantly, I've used Fast API talks to automate the complete stuff. I used a cookie cutter for my data science project structure. I use lint, type check. I'll publish all these things, don't worry. So I have a data scientist who took the data from a feature store or some public repo, take it. You have a developer who commits the code. Okay, Both of these things, I'm using a hosted Circle CI here. So Circle CI/CD is an orchestrator here. Okay, it takes both of these things, collaborate it, start the continuous testing. While doing the testing, it requires a lot of dependencies, pip install dependencies, correct? Those things would be resolved in JFrog Artifactory. And once I complete everything, right, I create a model out of it. I push the model as well as the data plus the configuration. What do I mean by configuration? The environment variables, the hyperparameters, the egg info, the structure of the project. Everything, I'm combining it, I'm pushing it to JFrog for future tracking. And I'm creating a wheel distribution out of it. So if somebody needs to install the model, pip install model from Artifactory, you're good to go. Once I push the model to Artifactory, right, X-ray will automatically kick in and start the scanning process. It looks for security vulnerabilities and tells me these are all the vulnerabilities, Arun, you need to be aware of. Okay. Once I do that, the next step is I'm going to Dockerize the complete model with a fast API. Why? Because Docker is still one of the famous, predominantly used technique to serve model as a service. Okay, I'm going to convert or Dockerize a particular image. I'm pushing it to Artifactory again. I don't need to go to multiple places like Docker Hub or multiple places. Okay, I need single Artifactory URL. I'm pushing it to Artifactory again. Once I push it, X-ray will scan it again, the Docker image, because Docker contains multiple layers, right? I'll show you what do I mean. You have a base image, you have multiple layers of dependencies. Any layer might have a vulnerability which might make your particular prediction go wrong, right? Or it can create havoc itself. So I'm ensuring that particular Docker image, which has my model, does not contain any vulnerabilities. Once I made sure of that, I'm going to deploy the Docker image into, I'm using a PaaS solution here, Heroku. I'm deploying it on Heroku. I deployed it on my own AWS cluster, but just for explanation, I deployed everything. I pull the Docker image from Artifactory, I'm pushing it to Heroku, and I'm monitoring the Heroku. If the performance of the model comes down, I will initiate the retraining. So I hope you understood the complete flow. Once I deploy it on Heroku, you can use an API. I'm using Fast API. You can use the API, right, to make a prediction whether it is cat or tiger. It's a simple thing. Okay, so I presume you understood the complete flow. This is a high-level diagram. Okay, I'm intentionally abstracting the low-level design. As I said before, this is a HLD. I don't want to dive into too much complexities, which might take you probably a bit more complex things. Okay, so before I dive on to the demo, okay, I would like to show you one thing. If X-ray scans a particular build, right, how does the report you get to know? There are multiple options. Okay, this is not a product demo session, but still, one particular thing is X-ray notifies you in the mail. So see here, I uploaded a particular ML API package into Artifactory. Immediately X-ray kicks in, and it sent me a mail today morning when I tested it. It sent me a mail. Okay, your package contains 218 components. Docker image contains 218 components. That includes my model, weights and biases. Out of 218 components, I found 55 violations, that is of critical top severity. So in this case, I'm not blocking it. I just want to show you the end-to-end life cycle. But this is how you can see in the email. Okay, you can also see in the UI. You can use REST API to automate everything. I believe you understood this. Let me show you the demo. I presume no questions. Okay, what do I mean by that? All the code I'm maintaining in my repo. Okay, I'm maintaining all these things. I'm creating a simple regression model. Okay, I'm also creating a neural network, but I'm not diving into machine learning development here. Okay, let's focus on the machine learning deployment. So I'm using Circle CI, as I said. These are all the various steps I included. I reduced a few steps because it took more time. Okay, I'm doing once I create a model, I'm doing a regression testing. Regression, it is a type of machine learning where I'm predicting continuous variable. Example is predicting a house price. I'm giving these many features. What would be the house price in Bangalore in KR next year? That is like what we call regression. Okay, I created a model for it. And let me show you what regression does. It spin up an environment. Okay, prepare environment variable, check out the code, and run all the tests I defined. It run all the machine learning tests. I automated everything. and I orchestrated using Circle CI. Now this is like an ML infrastructure test. Once I do this, next step, I did ML API. Because I've used an machine learning API, right? That is a fast API. I also need to test other parts, different complexities I need to touch base, just to make sure everything is working properly. In ML, there is a concept called differential test. Ideally, what it means, I'm taking a model that I deployed last week, I'm taking a new model, comparing it. Differentiation, whether this model has any improvement over the other one. These are all technical things, leave it. This would be done by the data scientist. But as an ops person, you need to orchestrate it. This is how I orchestrated. Once I made sure all these things are done, I'm taking a new data, I'm spinning up an environment, installing dependencies from Artifactory, then train a model, okay? Then I'm pushing the model to Artifactory. Once I push the model to Artifactory, right? Artifactory works on a concept called checksum based storage, okay? You can look into that. What do I mean by checksum based storage? It is one of the optimized storage that we do. That is one of the efficient way and loved by a lot of our customers. And once I upload a particular package, that is like this is the machine learning model, and this is the metadata and the data, okay, the details about the experiment. This is how it looks like in Artifactory. Probably I might take a few more minutes, guys. Bear with me. This would give you an end-to-end understanding of the MLOps flow. Okay, so I trained my new model based on the data, based on dependencies I fetched from Artifactory. And once I did the training, I'm uploading the model to Artifactory for storage keeping. So this is how the Artifactory, the platform will look like, JFrog platform. And guys, if you are interested, you are free to create a free account. You would get a similar access to this. Okay. This is the application view. I'm storing all the data in the artifacts here. So what I did, I uploaded the particular model into the Python repository. So as you can see, this is a Python repository. Artifactory supports more than 30 different packages. Okay, here I uploaded the model. This is the model, and this is the information about the experiment. What do I mean by that? So this particular model, right, have used this particular project structure, and this is the config, this is the data set. I'm storing everything. This is just like a feature vector, okay? But there are few advantages, there are few disadvantages too. But on a nutshell, I don't need to touch base at multiple tools, multiple endpoints, just to manage my MLOps pipeline. All I need is a single Artifactory to store everything. I don't need to worry about the other tools and other stuff. Okay, all I need is a single URL. Everything would be taken care of. So it stores the data as well. For this particular experiment, for this model, this version, these are all the hyperparameters. These are all the data. These are all the different models I've generated. Okay, this I generated a regression out of it. Okay, I'm storing everything here. So I also indexed. That means X-ray will kick in and look for any vulnerabilities. I intentionally did not include any packages which contain vulnerabilities. So X-ray didn't say anything. So the next step, once I publish it to Artifactory, right? Let me go to the next step. Okay, guys, don't worry about tools and other stuff. The steps will be different from each ops teams to ops team, but this is a generic flow that you can follow. Once I do that, right, there is two aspects. You also need to consider the CD aspect, right? What is the CD aspect? Continuous deployment, right? Not only delivery. I'm doing both the things here. I'm doing a continuous delivery as well as continuous deployment. What do I mean by that? I'm checking out the code, setting up Artifactory as a remote Docker engine, remote Docker hub. I'm logging into Artifactory. Then I'm setting up Heroku CLI because I need to deploy it on Heroku. Then here is where the magic happens. I'm downloading all the things. I'm pushing the particular Docker image which contains model, right, into Artifactory. So it goes here. It goes into, let me show you that. This is a virtual Docker repository. So I pushed the complete Docker image into this particular repository, which contains the latest thing. And these are all the checksums, okay? You won't get to see the data. Until you download it or you use the other thing, you won't get to see the data, okay? So your latest Docker image is loaded into Artifactory. Now, this is where the security kicks in. So in this case, I've introduced certain vulnerabilities. inside a Docker image, right? So X-Ray has a feature called deep recursive scanning. What do I mean by that? If you take a Docker image, right, there would be multiple layers. You have a base layer OS, you have an application layer, you have logic, multiple layers would be there. And every layer will have its own dependency. So in this case, right, let me try to find a good example here. All of these things are Docker images. Okay, let me open a Debian thing. So in this case, right, this is one of the Docker image. In that particular Docker image, in this layer, X-Ray found a vulnerability, and it gives the complete information about that vulnerability. It says this is severity high. You need to consider this. And also, right, if you have the fixed version, it tells you the fixed version as well. You need to, if it is available. In this case, it is not available. If the fixed version is available publicly, it will tell you, okay, Arun, you need to upgrade to this particular version to resolve this. It gives you the remediation as well. And it doesn't stop there. It sends you a notification, as well as you can make your build failure. Okay, what do I mean by that? I will show you one case. So if X-Ray says, I found these many vulnerabilities, so let me fail the build in CI server. So the particular Docker image, right, it won't get to production. It will get solved at the CI level. It's CI level itself. That is the shift left. Okay, so once I do this, I published it to Heroku. We have a command line tool. I publish to Heroku the container. Okay, I publish the container in Heroku. So you can now send a JSON request, or it's a REST API. You can send an API to get the predictions out of it. So I added some monitoring aspects to this Heroku, and it will automatically kick in the retraining aspect as well. But I think this would have given you a complete end-to-end flow of how the MLOps pipeline can work and how you can leverage the existing DevOps, right? So I think that would have probably made some useful information out of it. I hope there are no questions. If you have, I'll be there in the YouTube channel, so you can ping me. I'll be there to answer anything. Last but not least, thank you. And we are hiring an exceptional engineers like you. Please feel free to check our career site. Okay. Thanks a lot, guys. Thank you for your time.
Thank you. Thank you, Arun, for such a detailed slides. Like I really have to go back and try to get access to your slides and see what are the things. But it was really good, really detailed information.
Thank you.
It was great, Arun. Thank you.
Thank you.
Good way to finish a day of talks. It was a great topic, and I think it's one that we're going to be hearing a lot about over the next few years.
Okay, so I think there is one question. Maybe Arun, you can take care of that.
Let me look into it. Just a second. Which question you're asking?
Okay, so there is a question like how to maintain with Docker V1 need bug fix when we are running V5.
Okay.
So please explain how the process would help with the real-time example.
Okay, so when it comes to Artifactory, I'm assuming you're not talking about Docker version 1 and Docker version 2. Since you mentioned version 5, I presume you're talking about different versions of the Docker image. Okay, I hope I got that point correctly. So in case of an Artifactory, right, we do provide a lot of different properties that you can enrich. That is what we call build info. Too many informations are there. You can easily add properties and share all those things. If you are interested, I will probably share you a good resource link where you can learn more about Artifactory and other stuff. Okay.
Okay. Yeah, I think that was the only question. Thank you, Arun, for your time, and it was like we really enjoyed it.
Thank you for the feedback, guys. Have a good.
Yeah.
And it's a really nice thing what you're doing to the community, and I'm really happy to be part of a company where we are also trying to give back. Thank you, Ari, and thank you, Ajit, for this. See you around.
Thanks,
Arun.
Thank you, Arun. Okay, so we are towards the end of today's events. Okay, so so there are a few things which I really want to go ahead and share it with you guys. So the first and foremost thing is I would like to thank all our speakers. Thank you for all your hard work. There has been a lot of effort which has been put. I do understand that looking at the slides, the volume of the contents and all this thing, I think there is a massive work which has gone into preparing those slides, right? And and especially Ari, I want to thank to you and your team for sponsoring from a StreamYard, for our Collabnix community, and also for the cool swags which you have delivered to all of our speakers. So that they are really cool. Like I'm just looking at the the Liquid software book, and I want to spend some time looking into it, trying to understand the aspects. So I have a good book for a weekend for sure.
Nah, that's wonderful. Thank you
Yeah.
so much. We really appreciate that. You know, one of our core values at JFrog, which I really love because it's why I get up every morning really and go to work, is community happiness. And you know, it's not customer satisfaction, it's not community satisfaction. It's customer and community happiness. And so when we get to do those things with the community, it's really in the heart and soul of what JFrog is all about. So it's just we really appreciate the opportunity to be part of your community, and we are part of your community. We have our office in Bangalore, and it's growing. Over 100 employees there now. We hired, as a company, we hired almost 400 employees as an organization during COVID. So a lot of exciting things taking place, and it'd be nice to get back to some in-person meetups. I'm looking forward to coming to India and coming to my first Saturday set of meetups as well.
Yeah, sure. Like we are having,
and I hope it's at your community that I get to do that. So thank you.
Yeah, we used to have a lot of in-person events, which was like a mini conference for us. But it's really nice to see, like in the last year and this year, we have been like after every 3 months, we have been doing such kind of an events. And to just not to miss out few of the things for the community members. So all of these videos will be available over YouTube. And regarding the slides, yes, we will be shortly be uploading all the slides to Docker Bangalore GitHub repository. So, and if you have any questions, you can always join Collabnix Slack, and we can discuss about any kind of a collaboration for future events. So, Ari, is there anything you want to go ahead and share it?
Just I'll share the slide one more time for those who got here later. We are going to the raffle is going to close soon, but we're going to be giving away, I believe, 50 shirts and books based on a raffle drawing. So let me go ahead and share the slide. And let's see here.
Okay.
We look forward to you doing that. And here we go. But you can scan the QR code, or I know that you've brought up the link that is in the chat multiple times. So we're just really excited about picking some winners, and the winners will be contacted via email after they're selected within 2 business days. So that's pretty much it.
Okay. So with this, I want to say thank you to all. Have a great day, and see you in the next event. Thank you.